Community Day is soon starting, please turn all on your electronic devices and turn your cell phone to louds. It's also advised to eat popcorn during this meeting. It's remote, we don't care. Hello everyone and welcome to our first cert-manager community day, streaming all around the world, from every office in the world to every bedroom in the world to every kitchen in the world, and if you really want, also every toilet in the world. Today we brought you 4 hours of jam-packed amazing content, so let's get started quickly. My first speaker is Matt Bates, CTO of Jetstack, who will tell you all about what's to do today. Hi Matt.
Hi Martin. Hi there. Hopefully everyone can see me and hear me. Welcome to you all. It's fantastic to get you all together for what is now the first ever cert manager community day. We're calling it a day. It's 4 hours. So half day, a sort of pretty packed agenda. I'm really thankful for everyone making the time today, and obviously especially the speakers. I think we've got a really good one lined up. So this is our first one. We're running this live, so wish us luck. Hopefully this is all going to work without glitch. Don't worry, it is recorded. So if you want to come back, watch some of these talks at another time, we're going to make them available on YouTube on our channel, and we'll be sharing the link so you can sort of in turn share those with friends and colleagues, who can't make it today. Special thanks goes out to Marcia. She's got an awesome setup. If you follow her on Twitter, you'll be able to see the rig that she's got, and if you're not following her, do follow her and find out how she's doing it, because it's pretty awesome. So I'm hoping today is going to be great. She's really prepared, plenty for today, and she's supporting today's event together with the cert manager team. So thank you to them all for putting together today, getting us to where we are. Hopefully it's going to go really well. Just to be clear, right, we want to really make this as interactive as we possibly can, hence choosing something like YouTube. So if you've got any questions, please share them with us. There are going to be specific Q&A sessions after talks. Please join that time. Post the questions, put them into Slack, put them into the YouTube live chat channel. We're really happy to take those, and we're going to be moderating those. So I'm going to be in the chat channel. We've also got one of the newest cert manager engineers on the Jetstack team, Jake, and he's going to be moderating with me. We're going to be taking those questions and giving them to the speakers. So please feel free to get involved. So 3 years in the making, cert manager, we're now at 1.0, which is an awesome achievement. I'm sure we'd all agree. Many of us have probably been using it in production for quite some time. I know we have. And then we know many other engine operators have as well. So it's been really great to be able to get to this milestone, and you don't get there without a lot of hard work and a lot of real contribution from the community. So it's a great time to celebrate where we've got to. The downloads are pretty impressive, as you can see from the numbers here. It's a really widely used and downloaded tool in the Kubernetes ecosystem. Quite incredible really when you see some of the numbers, and all of those are public, so if you want to go and kind of see those, go and find the key container registry, and it'll give you some of the stats. Lots and lots of GitHub stars, of course, lots of code contributors, so we're very thankful that we've been able, and proud that we've been able to support the project and invest in James and the team very early, but of course it's a community that's grown around it. And over 250 people have contributed in various different ways, major contributions, but also through code, of course, through documentation, through even just supporting the community. All of them are valuable contributions, and we're thankful for each and every one of them to get us where we are today. Lots of issues open, lots of PRs kind of merged, and over 77 releases. And of course, the latest here is this sort of 1.0 milestone that we're at today. What people new to the project may not realize is that there's been a number of projects which have been sort of come before it, which have enabled us to get to where we are today. So Kube Lego, which some of you may have come across, was almost like the predecessor, and that was focused very much on Let's Encrypt, and very popular and widely used. We managed to sort of learn a lot from Kube Lego, and indeed other projects in the community as well. There are a number of other projects that sprung out in order to solve this kind of issue of certificate issuance and renewal. So kind of at the very beginning, James and a number of people in the community brought together those projects and rethought how this should how this should work. And of course, here we are today with a project that's ubiquitous and now used extensively across the community. So a massive thanks goes out to everyone. And you may have seen already, if you're a maintainer, and I know we've probably got a number of contributors and maintainers on the call today, but if you're not, you may have seen it on Twitter. We sent out thank you notes to everyone just to say thanks to everything. So these have made their way around the world pretty much. I know a number of people who received them across Europe, across the globe. So thank you to everyone for your involvement. I think we're really happy to get to this stage now. Of course, we can take off that not for production use notice that had been on the docs for quite some time. Really happy to get to this stage now where we've got the API stability, and I think Marcia will talk a bit more about this when she talks about 1.0 and some of the where we're pretty much at the moment. One thing that's worth noting before we get to the agenda is that we've really proud to have been involved in the project and be able to invest in it throughout the several years of its lifetime. And we're very committed, of course, to it being in the open, so much so that we're at the moment working on a donation to a foundation. So a foundation near you will soon be getting a donation of the cert-manager project. So we're working on the specifics of that at the moment, but really thrilled to announce that in the coming weeks. So you heard it here first. We'll be making our way to a foundation, all being well. In terms of the agenda, lots and lots of content. Hugely thankful for a number of people making their time available today. End users, maintainers, and members of the JetStack team who work on various parts of cert-manager and its integrations in the ecosystem. So thanks to everyone that's here today. Just a very quick run through of who we're going to be speaking to. Marcia's going to be speaking to us about 1.0, of course, hot off the press. She's going to be telling us a bit about what's in the latest release. I'm sure you'll really be happy to hear some of that. We're then going to be hearing from Josh on the cert-manager team at JetStack. He's going to be talking about some of the integrations with service mesh. So not only it being used for the control plane, but indeed for workload certificates that are actually in the mesh. And that's both open service mesh and I believe this year too, Josh. So we're going to be seeing some of the work that he's been working on. We're then going to be hearing from Danielle. She's going to be talking to us about how it can be used for webhooks. So as we know, cert-manager tends to get used mostly for ingress, but it actually can be used internally for Kubernetes webhooks. And so she's going to be talking a bit about how you can use cert-manager to secure those. We're then going to be moving to Alex. He's going to be about his project Inlets and some really advanced ways in which you can use it in conjunction with cert-manager. Really looking forward to that one. Thanks, Alex, for joining us. We're then going to be hearing from Let's Encrypt. I'm super excited to hear a bit more about what Let's Encrypt are doing, where they're going, maybe perhaps even some numbers. Josh, we're looking forward to, and we're really kind of keen to hear. We're then going to be moving to Richard. He's going to be talking to us about Kubernetes node certificate provisioning. So we've been working, Richard's been working quite closely with the upstream communities there in order to integrate it with the likes of KubeADM and cluster APIs. So Richard's going to be talking to us a bit more about that. We've then got a session where you can ask us anything or ask the team anything. So we'll be moderating that, taking questions. So please have your questions ready, put them into the chat channel. And we've got James, we've got Marcia, we've got Josh, we've got Richard, who are going to be part of that session. So please get your questions at the ready for that. We're then going to move to Josh. He's got a second talk. Thanks, Josh. He's going to be talking about how to integrate with Vault. Of course, Vault being one of the CAs that you can use in addition to Venafi. And Let's Encrypt. And finally, I'm really thrilled to be joined by Anurag from render.com. And they are using cert-manager at TrueScale. And so I think tens of thousands of certs, if I'm not mistaken. Really popular platform that they're building over at Render. So thanks to everyone. I think it's going to be a great lineup. As I said, all being recorded, all available later. I think without further ado, I'm really happy to hand over to Marcia for the first session. Enjoy, everyone, and thanks for joining.
Thank you, Matt. So hi, I'm Marcia. My common name is Marcia, and my X51943 extensions are developer, community leader, and train lover. This actually has been tweeted to me today, and I liked it so much I wanted to be in my slides. So I'm going to talk to you about Cert Manager v 1.0, which we named a seal of trust, because we're now putting a seal of trust of 3 years of Cert Manager development by now calling everything stable. But while Cert Manager v1.0 is mostly a stability release, we also have 3 focus areas. One of the focus areas is making Cert Manager future-proof, making sure that your Cert Manager installation still works in the next version of Kubernetes, and making sure that you can rely upon Cert Manager. We're also making Cert Manager more user-friendly, and we wanted to show some extra love to Acme, because this is still the most used use case for Cert Manager. Let's talk about future-proofing Cert Manager. The biggest change in Cert Manager 1.0, which you may have seen, is the v1 API. The v1 API is our first stable API, which we will promise stability for the years to come. The v1 API is a graduation of the v1 Alpha 2 API, which is widely used, and the v1 Beta 1 API, which was introduced in last version. The v1 Beta 1 API introduced a lot of improvements documentation-wise about the API. We reviewed a lot of comments in there and a lot of documentation on our website and in kubectl explain. If you don't know it yet, you can do kubectl explain and then certificate, and you will get all certificate fields as Cert Manager offers. v1 Beta 1 also brought a few improvements in renaming some fields to be more clear to the user what they do. We took all this awesomeness of v1 Beta 1 and put it inside v1. v1 added one tiny change to v1 Beta 1, and then we dropped the term sen, because now with the common name being deprecated, we found that the alternative names are now the main star of a certificate. So this is what a certificate now looks like. API version cert-manager.io/v1. Looks good, doesn't it? So as always, your kind is a certificate. And this is a certificate for example.com, which we have a subject field, which is nicely organized. What's new is our private keys. So our private key values are now in a separate struct inside the certificate, so you know which values specifically apply to the private key. And we also have DNS names, IP addresses, which are now nicely named. So how do you upgrade to this v1 API? Well, if you use Kubernetes 1.16 and above, you just upgrade Cert Manager. Cert Manager will take care of all the migration for you. You can even still submit old manifests that you have lying around. Cert Manager will convert them around for you. If you use Kubernetes 1.15 and below, really, we advise to just upgrade to Kubernetes 1.16, because then you can use this conversion mechanism and you will be running a supported version of Kubernetes. If you, for some reason, cannot upgrade, no worries, Cert Manager will support you back to Kubernetes 1.11. However, there is some migration path which you have to follow, but we created an easy tool for that in a kubectl plugin, which is called Convert. So, talking about user-friendliness, we, a few versions ago, introduced a kubectl plugin. If you haven't checked it out, go install it. So this allows you to do kubectl Cert Manager and configure your Cert Manager resources. We now added a status command. So you can now do kubectl Cert Manager status certificate and a certificate name. This will then give you all that Cert Manager knows about the certificate. So this is now the first all-in-one command to help you with troubleshooting. If there is any issue in any step of the process, this command will show you. More user-friendliness stuff. We improved our logging. So Cert Manager is now built on the clock v2 library, which is the same logging library that's used in Kubernetes 1.19. If your logging tooling can parse anything like kubelets, API service, etc., you can now use the same exact tooling to parse the Cert Manager logs. While doing this, we also reviewed every single log line in the Cert Manager codebase to make sure it's up to date, it's clear, and it has the right log level. By doing this, we ended up with 5 log levels. You can now choose, to your own taste, which log level you want Cert Manager to run on, from showing only errors to show everything that's going on inside the cluster. And lastly, we love Acme. And by showing our love, we added 2 new things. The first thing is the disable account key generation function. If you set this to true, you disable the Cert Manager functionality that will automatically ghost create a new Acme account for you. Why do you need this? Well, if you have a large deployment of Acme certificates like the talk about render later today, you probably have an account that can bypass rate limits. This now allows you to very easily install accounts everywhere and make sure you don't make mistakes. if the account is not valid, cert-manager will now tell you and not go try to fix it. So this is an extra safeguard for running large Acme deployments with cert-manager. The next thing we added is the preferred chain function. You may or may not know that Let's Encrypt is changing over from cross-signing with IdenTrust to their own root certificate authority, the ISRG root. For that, Acme now supports issuing certificates from multiple chains. And then cert-manager can now just pick a chain for you. So this is a field on the issuer which you can now specify which chain you want your certificates to come from. If you want to keep using the IdenTrust root as long as it's available, you can do so by setting the preferred chain to the IdenTrust root. If you today want to use the new root CA, you can use the same exact feature to do that. This feature is already added to Certbot, and we implemented our behavior analog to that, so it's easy for users. So that's everything what's new in cert-manager v1.0. I thank you for coming to my presentation, and stick around because the next one up is Josh. In 4 minutes, he will be talking to you about service meshes, and he might have some exciting news. Hello, welcome back. So we're talking about service meshes, which might be the most demanded feature request in cert-manager. Well, if that sounds like music to your ears, Josh has very good news for you today. Josh has been working with the cert-manager team since the very early days, and he's doing a great job. Especially now, he's working on integrations with Open Service Mesh and even Istio. Hi, Josh.
Hello. Thank you, Marsha. Hi everyone. My name's Josh. I'm a customer reliability engineer at Jetstack, and I'm part of the cert-manager team. Have been for a number of years. Today I'm going to talk about service mesh, so integrating cert-manager service mesh. Like I said, my name's Josh. So it's a quick talk to kind of go through what service mesh is, kind of what value it provides, why we're deciding for cert-manager to be integrated with service meshes, the current service mesh integration with open service mesh integration with cert-manager, and then beyond that to kind of the other integrations that are planned, for example, with Istio. So first thing, why are we choosing to integrate cert-manager with service meshes? So the way we see cert-manager, cert-manager by definition is a X509 certificates controller for Kubernetes, right? So we manage X509 certificates and therefore machine identities. And there are three key areas which we foresee where cert-manager can kind of fix, or not fix, but kind of manage the certificates in these areas. So first of all, being the infrastructure. So these are your Kubernetes components, such as webhooks, for example, but indeed beyond that, potentially with the Kubernetes nodes, which we're going to talk a bit about later. Also with that, so we then have ingress, which is perhaps the most common cert-manager use case. This is kind of classic securing your kind of public-facing host names using something like Acme. And then finally, the third area that we kind of foresee is the kind of intra-workload TLS. So these are the kind of the workloads running inside your cluster securely communicating with each other over TLS. And this can be facilitated, for example, with the kind of experimental cert-manager CSI, or perhaps even the kind of service mesh. So what is service mesh? You've probably heard about it kind of in the Kubernetes space. It's sort of taken over the hive mind recently, and there's many implementations of it. But what is it? What is it kind of really? So the service mesh is, from a very high level, is the idea to implement security for the traffic between your workloads, to expose traffic and introspection on the kind of traffic between your workloads, and the management of traffic between your workloads, so traffic splitting, things like this. And as well as authorization, so making sure that the calls are kind of being authorized to the right places. So fundamentally, what this means in your kind of Kubernetes environment is that we install a proxy sidecar to all the workloads running in your cluster, typically Envoy sidecar. And what happens is this reroutes all the traffic through your main workloads through this Envoy sidecar. And that's a sidecar should be kind of configured as such that it can kind of route that traffic whilst kind of having identity about itself. And what's nice about this approach is that you can implement this kind of service mesh on top of your workloads in Kubernetes that's completely transparent to the workloads themselves. So what happens is these Envoy proxies will come up and they will speak to the mesh control plane, which is another component running your cluster, and they will request for a certificate, which will give them some identity. And then will be configured from the mesh from then on how to make decisions about egress or ingress traffic through that sidecar container. So since this is all based upon identities that are encoded through certificates, it's kind of a great fit for something like cert-manager to come in and facilitate that management. The reason being, of course, with cert-manager that you have access to X number of issuers, which can be transparently configured above this control plane without having to configure kind of any of the underlying components. So yeah, it's a kind of very natural fit for something like cert-manage to come in to kind of facilitate that. So first to integrate was the Open Service Mesh. So Open Service Mesh is Microsoft's addition to the kind of service mesh space, and it's considered maybe a kind of simple or a kind of simple approach to doing service mesh in the kind of guise of it being easier to maintain and use. And it's based upon this service mesh interface, or SMI, which is essentially a set of configuration specification in the similar vein to something like CNI, for example, or indeed something like network policy, where you have a consistent configuration that can be implemented on many different service meshes, and you, as the end user, you don't necessarily need to be aware of the underlying implementation, which means that your kind of infrastructure or your configuration can be more transferable between the kind of implementations. So this was our first integration with the service mesh. And this integrates straight into Open Service Mesh, meaning that Open Service Mesh is kind of imported cert-manager code. And as I was saying before, when the Envoy proxies come up and they do a certificate signing request against Open Service Mesh, the control plane, so this would be in this case the OSM controller. The OSM controller will then go ahead and send a certificate request off the cert-manager using the kind of pre-configured issuer. And yeah, this was great. This is quite good implementation. So in fact, I've a client cluster running locally with Open Service Mesh running. And you can see here that I've got the controller running here and some workloads running along with cert-manager. And indeed, if I get my certificate requests, you can see I've got a number that have been signed here for the workload certificates that have been joined onto the Open Service Mesh cluster. And yeah, this is super, so just kind of worked. So the integration, there wasn't many problems at all. And it's quite nice to see that, we built this cert-manager API and in the kind of foresee to have it pluggable. And yeah, no, this is quite simple to integrate, and yeah, it works quite seamlessly. And indeed, like I was saying before, the power of this, for example, is you can kind of transparently add any issuer to implement the kind of control workload or certificate. So quite recently, Skyscanner released a AWS KMS external issuer, for example, which kind of shows the power of cert-manager having your Open Service Mesh workload certificate signed by an AWS KMS certificate without needing to kind of wait for any upstream configuration changes or upstream changes to Open Service Mesh. For example, you can simply use cert-manager as an intermediary kind of stable certificate API. After this integration, the next one, it was kind of clear we wanted to do Istio. So Istio is another service mesh you've probably heard of, driven by Google, which has a very rich, extensible feature set, supports multi-cloud on multi-cluster, and it is the kind of driving force behind Anthos, for example, to kind of get a lot of that functionality working. So in the Istio's example, it's slightly different. So in the current implementation that I'm working on, which I hope to be in a working state soon, is instead of the kind of requests from the Istio agent when it comes up to get the certificate request signed, instead of it sending it onto the Istio D component, which is normally responsible for the certificate signing, instead we'll be sending it off to a cert-manager Istio agent, which is effectively exposing a gRPC service. Once our agent has validated or authenticated the request using the JWT that gets passed through from the agent, this will be the Kubernetes service account JWT, and we've authorized the certificate request. We then go ahead with the normal flow, creating the certificate request, and then that getting signed off by our configured issuer. So in this case, we have Verify here, and that will get passed back through the gRPC service back to the Istio agent and be used by the Envoy sidecar container. Great. So moving forward into the future, for the kind of a later implementation is we're quite keen as kind of a cert manager project to integrate with the new upstream Kubernetes certificates API. So this is an API that went V1 as of, I believe it was 118. And this effectively implements something close to the cert manager certificate request resource as a kind of internal upstream certificate signing request API in Kubernetes, and facilitates some things which we could have some difficulty implementing. So, for example, the upstream Kubernetes API facilitates an identity straight onto the resource itself, which is managed by the API server. So that opens the door up from future, you can imagine, for policy enforcement for certificates and things like this. But indeed, in the future, when we implement these controllers as well, instead of the Istio agent having to send off the CSR to some cert manager Istio agent, instead it will create the resource in the Kubernetes API, and then our cert manager kind of standard, core controller will then validate that request and get it approved and then signed by us, but via the configured issuer. In this case, I've got Benify here as well, but of course, using Cert Manager, it's fairly easy to kind of swap out which issuer you're using. Great. So that's me for my quick lightning talk with serverless meshes. In future, yeah, I'd love to kind of integrate with as many serverless meshes as possible going forward. And I think it's certainly an interesting area for me personally, and what I've always kind of wanted to see out of the kind of Cert Manager project, kind of facilitating more of those kind of bullet points that I showed earlier on that slide about where we want to manage certificates. Don't know if there's any questions potentially, Marsha, from anyone?
So to everyone who's watching at home, you can now ask questions in the chat. I will throw them away to Josh. Oh, Josh is over there. It's all mirrored. So if you have any questions, leave them in the chat. I'll pass them on. Josh, while it's not a question, Lewis says thank you.
Thank you very much.
While we're waiting on questions, the next speaker is Danielle. She will be up in about 3 minutes here on stage, virtual stage. After her talk, we'll take a 10-minute break. So if you want to grab some more food, some more popcorn, you can always take your laptop with you. But if you don't want to do that, you have a 10-minute break soon. Josh, I think it was a nice talk because people are only applauding and saying nice talk and no questions.
Absolutely perfect talk. Awesome. Well, I'll just plug my next one. So later on in the day, I think near around 7 p.m., I'll have another talk about Cert Manager with Vault. And I'll be discussing how we can leverage the Vault certificate policy that I mentioned just now about what we'd like to do in core Cert Manager, but indeed we can leverage Vault's internal certificate policy and how we can use that to configure a cluster with multiple tenants and securely delegate certificate management to the tenants of the cluster and allow them to only kind of request certificates that they should request for. Yeah, wait till 7 p.m. to hear it from that.
That's 7 p.m. PST for the people who are wondering which time zone. Thank you very much, Josh, and we'll see you all back in 2 minutes. While most people use cert-manager to secure ingresses, cert-manager can do way more. For example, one of the things it does is securing itself. But what if we could use that same technology to also secure other Kubernetes operators? Well, that's what our next speaker is talking about. Our friends call her the queer who yells at clouds, but you can just call her Danielle. Hi Danielle, welcome. And we have a frozen connection. Be back in a second. Sorry, you're buffering. We also fix something here. So it's all the internet. Let's try again. Hello, Danielle. We can see her, but we cannot hear her. That's not good. We'll be back.
Love technical problems.
Well, we cannot hear her. We can hear her. Oh, wait, reverse. Sorry. So I just told her to start in 15 seconds. The talk is about to start any moment now.
Hey, so I'm Danielle, and I'm going to be talking about something that I don't think many people might realize you could use cert-manager for. That's kind of annoying. And that's when you're sort of building like platforms on top of Kubernetes and want to extend Kubernetes with things like operators or admission controllers and, other similar things. So what is a webhook in Kubernetes? A Kubernetes webhook is something that lets you extend the core functionality of Kubernetes with various different things. So there's a few different types. The first would be a validating admission controller. This means that when you submit new resources to Kubernetes, the first thing that will happen, well, one of the last things that happens is they go through a set of validating webhooks. And what they can do is they can sort of like either accept or deny objects based on pretty much anything about the object. And in my demo later, I'll be showing you one of these in practice and like sort of how cert-manager helps you build those. Mutating admission webhooks, what they do when an object first enters Kubernetes is they will go through all of the mutating webhooks, and then they can describe a set of changes that they want to happen to the object. Say, for example, you wanted to make sure everything you submit to Kubernetes has like a name prefix or like default values for like requests or similar things. What these can do is they'll receive those objects, they can send those changes back, and then those changes happen before they're validated and accepted into Kubernetes. And the third type is CRD conversion webhooks, which are relatively new. But what they do is if you have CRDs with different versions, a conversion webhook will be used by Kubernetes to figure out how to return different API versions of the object. The problem with Kubernetes webhooks is they require TLS. And that can be really annoying when you have like a lot of different environments or a lot of different resources that you want to manage, because OpenSSL is really hard. So we'd rather use cert-manager for that, right? So that was a short introduction. And now I'm gonna like switch to terminal, which I hope is working because I don't know how Google Meet works. So what we have here is a simple little webhook that what it does is for every pod you try submitting to Kubernetes, it validates that it has CPU and memory limits. And if neither of those are true, then it will reject the yeah. So what happens here is if there are like, if there's any container that doesn't have a resource limit for CPU or memory, then we reject it. Otherwise, we continue and everything is okay. So we have to run that in a cluster. It just so happens that I should have one that works. Yes, my kubeconfig did not expire. So to do that, we have a couple of different ways of doing it. First, I'm going to show you how you would do this before cert-manager using some sadness with OpenSSL. So if we look inside here, we have a templated deployment that has our admission controller. It has a container with our webhook server that mounts in some secrets to serve over TLS. And then we register the validating webhook configuration, and we template in the CA bundle that the Kubernetes API server is going to use to validate your TLS certificates when trying to talk to your webhook. The way that gets populated and the certificates get generated is through a couple of different things. First, we have this bash script that will generate a self-signed CA and a certificate and private key that's going to be used by the demo server. This is kind of sad because as of Go 1.15, and therefore newer versions of Kubernetes, Go will no longer use the common name when validating certificates, which means here we have to set up stuff to support subject alternate names in the certificate, and set up the policies correctly, and then we can create a certificate for the internal service name. So you'd need to do this for basically every different webhook service you'd have in your cluster. Then what we have is a script that actually finishes the deployment. So it generates certificates, creates the namespace, creates a secret based on those keys, renders the deployment YAML, and applies it to Kubernetes. This is kind of annoying because it doesn't do anything around like managing expired certificates. Like, if you need to roll everything, you need to go and regenerate everything and redeploy, which is not so nice. But if we go and deploy that, I need OpenSSL. Oh, no, I don't want like a nested thing. Did I break something? Oh no. That is unfun. But I have some certs here anyway, so if we... What is funny is this was working like 5 minutes ago, but instead, if we set this to and don't do this either. If I could Kubernetes. Okay. So this time everything gets created. So now we can go and see that we have a validating webhook configuration called demo webhook. And if we try to deploy an application that doesn't have resource limits, we'll see that this happens. But then if we get the events for the namespace, you'll see that we denied the request because the container is missing required CPU limits. And so we'll also see that it created no pods. But then if we go into here and give it some limits, and we go here, amazing. Is my internet just being wonky? Okay, here we go. It just took a little time for Scaleway to make me a load balancer. But here we go. You see the app is now running. So if we take that down, and we also take down the app. What we can take a look at now is how we'd replace that with cert-manager, which gets a lot of benefits, not just through not having to use OpenSSL, which I actively try and avoid in my life because it's stressful and frustrating, but because it makes our life better and handles all of the rotation and stuff that would usually get you paged at 2 a.m. well, midnight, when your certificates expire. Because, you know, last time you regenerated the certificates was last time you had an incident at midnight. And then you like generate new ones for a year, being like, that'll buy someone time to automate this. And they never do. Or there was that one time where a CTO generated certificates that lasted for 10, 24 days. And then our CA expired and all of our databases were inaccessible. Which is fun times. So here we have basically the same deployment as we had before. We have some volume mounts that mounts the secret into the right place. We have a service. And then we also have a validating webhook configuration, but this is a little bit different to before. Rather than templating in a CA bundle, what we do is we annotate the configuration with cert-manager IO, inject CA from, and then you can specify either a secret or a certificate that you should automatically populate the CA bundle with. So the way we create that here is we have a self-signed issuer, because we're only using one certificate. You could also have like an internal CA that you use for like all of your webhooks, or, you know, various other ways of specifying your PKI. Then we have a certificate, and we annotate this to allow direct injection. What this means is cert-manager will allow that certificate to be used in places like this. Means that you can't like accidentally like pull in stuff that you don't want to. We set the DNS names that it should be valid for. And that's it. Like, that is all we need, and everything should just work. Which is like much easier to understand than like my mess of OpenSSL bash. Partially because I'm not very good with OpenSSL. But also because OpenSSL is hard to use. So if we now try deploying this, everything gets registered, and then what we should be able to do is CM demo, get certificate. See here that we already have our webhook TLS certificate, and oh, exciting. We ran into a fun problem where we left our old validating webhook configuration in here. And that is not what we want. Validating webhook configuration. We get rid of this. And I'm going to do this the easy way of deleting and reapplying this. Do a little dance while we wait for Kubernetes. Okay. And then reapply. So now we see that everything was created successfully. We can see here that we successfully injected the CA bundle despite not specifying it ourselves. And then if we try deploying our application, this time it's gonna, oh, no, that's not what I wanted. If we try deploying our application again, this time it should work straight away because we didn't revert removing the limits. Then Give Scaleway a little bit of time to create a load balancer. Ah. Come on, Scaleway. You can do it. I believe in you. Hey, here we go. And everything worked. And if like RCA expires, like cert-manager is going to take care of dealing with that. Like we basically never have to touch this again, aside from like updating Kubernetes API versions, which I think is pretty nice. So what did we learn? We learned that admission webhooks can be really useful. Outside of that contrived example that I used like everywhere, like cert-manager uses them for injecting the CA. There are like webhooks that do things like integrating with open policy agents, so you can specify any sort of rules you want on your deployment, and a bunch of other stuff. And cert-manager is really useful for managing like your internal PKI, because managing that yourself is really hard, and Google Calendar is not a failure recovery strategy for your certificates. Like, I'm sorry, it's not. And it makes everything much easier to get started, which is always a benefit. So, thanks. I don't know if there's Q&A.
I don't think there is going to be Q&A because you can't hear us, so thank you very much, Danielle. All code is available on GitHub. I'll make sure she also shares it here on YouTube later. Thank you very much. We'll be back to you very soon with our next talk.
Ooh. Hello? I think computers are having a set time. Cool.
We're having a 15-minute break, so feel free to take a toilet break, grab some extra drinks, or whatever you want. We'll be starting our next talk in 5 minutes. Be sure to fill your coffee mug, preferably a gopher or an inlet mug. Hello, welcome back. Hope you filled all those coffee mugs up. So Alex said he would give a free inlet swag to the best tweets. So I already sent out a selfie. So if you want to tweet about this talk, make sure it's a bad tweet so I win. Thank you very much. So last time I spoke, Alex had a nice Raspberry Pi cluster behind him. But that's not what he's going to speak about today. Today he's going to bring our cloud networks to the next level. And while doing that, he will kill all nasty VPNs. And how better to secure the future than with cert-manager. Hello, Alex.
Hi, thanks for having me, everybody. It's good to see so many friendly faces on the chat. Today, we're going to look at some advanced cloud patterns that you can actually employ with inlets and that cert-manager makes really easy as well. And I'm not going to say Istio once, hopefully, because you don't need it. It turns out that actually using existing tools, we can build really interesting networks and solve problems. So the best tweets today will be getting swag, so you know how this works. First of all, I'll tell you a bit about inlets, the proxy and the tunnel that you might have heard of, the traditional use case, but then we'll look at also what are the alternatives and what other things can we use it for. Particularly, I want to take you on a bit of a journey through use cases. I always think it's important to think about, great, well, what's the problem we're solving with this technology? The hybrid cloud will hopefully speak to a few of you. Multi-cloud federation, that's where we can actually federate Prometheus. I only found out about this last week, and it is very cool. And then we'll get a couple of demos with cert-manager in the mix as well, recap everything, and give you a few points to go off from there and try it out for yourself. So inlets started as an open source project. There's just over 6,000 GitHub stars on it now. There's more than one repo. There's not only the open source free version, but there's also a commercial version of it too, Inlets Pro. Now, what is it? Well, it's a service proxy, a bit like Nginx or Caddy, but it also is a network tunnel. And you may have seen network tunnels in the past in things like ngrok. Now, this differs a bit from a VPN, like Marta said. This is working at the HTTP or the TCP level. So we're not pushing IP packets around, we're actually talking to applications. And that's one of the things that makes it really easy and powerful. The way that it transmits its control plane is over WebSocket using TLS. Thank you, cert-manager, for helping with the TLS. Now, that means it can actually penetrate pretty much any kind of network conditions you can come up with. Captive portal, center parks, chalet, you name it. You can pretty much run this from wherever you like, even over a HTTP proxy. But unlike tools built 10, 15 years ago, or VPNs 20, 30 years ago, it's actually been built 18 months ago and enhanced since then for cloud native. So it's really looking to work with VMs, containers, and Kubernetes as a first-class citizen, Mac, Windows, and Linux. It's written in Go, and it's very portable. And it's also easy to automate, and I think that's because it's just been designed to do one thing, which is to tunnel traffic. And then we have these automation tools around it to help us put bits in the right place. And as I say, it can be used as a VPN alternative, but there are still lots of valid cases where you want the VPN instead. Now, when you think about networks, we have these private networks and public networks, and there's a very big difference between the two. Private networks, well, you just don't have a public IP most of the time. If you do, it changes, and you don't want to expose yourself on the internet. You need NAT to get behind the computers there. You've probably got a firewall if you're at work, and you maybe can't even open a port, or it's a big job to try and do that. When it comes to corporate proxies, again, it's hard to push traffic through them. Public networks, on the other hand, they're very easy to use. The world is your oyster. You get public IPs almost for free, but that is going to start coming to an end soon with the capacity dropping and then running out. So we've got pros and cons on both sides. The idea here is that we can perhaps bridge the networks together to get the benefits of both. Now, your traditional use case is you're running a client on your laptop. Maybe you've got a webhook receiver, written it in Node.js, HTTP port 3000. We've all been there. But we want GitHub to send us webhooks, and it just isn't going to work. Therefore, we can run a client which establishes a WebSocket outbound. That's how we get past the restrictions. Once we've got the tunnel, it's fair game. And when GitHub talks to us, it's like it's talking to our laptop directly. The terminology for that public-facing part of the IP is the exit server. Now, this is what it would look like if you use the open source version of Inlet. This is level 7 HTTP based. You have the client. You specify the URL of the server. This is a WebSocket, remember, and it's using TLS. You have an auth token that's symmetrical. They both share that. You say that upstream, just like in Nginx, where am I going to go when I get traffic? Well, I'm going to go to that node service. On the server, you have that symmetrical token again, and then you can bind either to all your adapters, or maybe you just want to bind to localhost and then let something like Caddy take over and provide your TLS. Now, that's probably the best use case for a VM running the open source version. But if you're inside Kubernetes, you can use Ingress, and you can use cert-manager to get your TLS instead. And we'll see that in a minute. Now, Inlet Pro gives you level 4 TCP style tunneling. So here we can actually do things like MongoDB, Redis, maybe Nginx itself. We can even tunnel that because the pure raw bytes will come back to your client from the internet. It's very similar. We have an upstream host instead of a URL. We have the ports we want to expose, and you can have a large list of them if you need it. There is a license, a JOT, that you can purchase. And then again, you need a URL where you're connecting to, the auth token. And so it all looks very similar, but Inlet Pro also adds its own PKI. So it can create and sign certificates for you so that if you're not needing to build like a complete infrastructure and automation with cert-manager, you can get something secure very quickly. Okay. Now, one of the benefits here is that it's effectively unlimited. You control this, you self-host it. So your control plane, that WebSocket, is secured with TLS. Great. No snooping. We can expose whatever ports we want. There's a strict access control list so that people can't just get into your cluster if they hack your server and start pinging other computers in your network. It's very important. And it encrypts the data plane. Now this one is a little bit harder to get your head around. You imagine we're running MS SQL, not MySQL. I'm talking about a Windows computer in your data center. And let's say it doesn't have TLS enabled and there's no auth on it. You're not going to expose that on the internet. It'd be a very bad idea. Well, what you can do is push it across the tunnel. It will encrypt the data. And then on the other side, whether it's a pod or a container or a bare metal host, Mac, Windows or Linux, you can then decide if that data plane is public or private. If it's private, then you can connect to it from within the cluster and make use of an existing asset, okay, without having to worry about potentially breaking that old Windows machine by trying to force TLS into it or force auth. And the alternative here is versus a VPN, right? But there's no IPAM woes, no routing, no Linux issues. You don't have to buy, you don't have to sort of go on to Stack Overflow all day long. It just works. Now, because it does a simple job, and you've seen those are the command line options, it's basically all there is, it's very easy to automate it. And we've seen a community ecosystem come up around it. And what these exist to do is to lower the barrier, because it is just too easy to use a SaaS tunnel, right? You type one command, it's live, you've got HTTP traffic. Very easy. So we wanted to try and make it as easy as that, but with self-hosted VMs. Now these cost between $2 and $5 per month to host. If you use an individual cloud VM just to expose one thing, use Inlet's control. If you've got a Kubernetes cluster, Marta mentioned my Raspberry Pis, and by all means run K3s on it, install the Inlet's operator, and then that will get you real IPs by creating those VMs, and you'll get traffic to your computer. You can also run this on your laptop. We'll see a demo of that. Terraform is fair game, so is manual setup, whatever suits you. Now remember, we need to secure that control plane. With the open source inlets, we tell you how, but we don't do it for you. We don't hold your hand. So if you're an expert, fair game. But Inlets Pro has built-in PKI. It has ability to use TCP as well, but both of them can use cert-manager. And if you have an enterprise CA, you can actually make use of that with NFI through cert-manager, which I think is pretty cool, pretty useful. More of that on GitHub. Now, where does this fit in? Because, we sort of think about this. Well, what is Inlets for? Is it an ngrok replacement? Is it a VPN? Nobody really knows, right? Well, this is where it sits on the cloud native landscape. It is a service proxy, but it doesn't really fit here because it also has superpowers. It's a tunnel as well. And I'll have to check, but I'm pretty sure none of the ones listed here have that. So we want to pair it to something else, perhaps, which would be WireGuard or a VPN. And this is something that people will often say, perhaps when they're not that well informed about the area, they'll say, well, what about X? And it's fair to say it. When you use Inlet, you're really looking at applications or services. There is a topology that looks a bit more like a star, where you have clients coming back to a server. I'm talking to a company at the moment, and they're thinking of doing sort of tens of thousands of connections of IoT devices back to a single control plane. You probably don't want to create a VPN mesh for that. It's going to be very messy. You run out of IP addresses, all sorts of issues there. But sometimes you do want a mesh where every computer in your entire facility, in site to site, they're all linked together and they can talk at level 3, which is much, much lower down. That's the IP level. And that might be what you need. If you're replacing a corporate VPN, if you want to access your Raspberry Pi from home, perhaps that's for you. So hopefully that gives you a bit of an idea, and I'll give a bit more detail now. So Tailscale, very popular at the moment. It's built on WireGuard. Really looking at connecting nodes rather than connecting together services. Okay. So when we think about cloud native and things like Istio with all the traction behind them, they don't connect nodes. In fact, they've moved away from node-based service meshes. It's all about the services now. But they have a real advantage that they work at the UDP level and they use that for transport, which means they're really fast and they can run a full stack of TCP on top of that if needs be. Now, the commercial offerings are build per user. We want to work with services, so it doesn't really map very well, does it? And there's no ability to have public tunnels unless you do a lot of extra work. Now, not to mention, if you've ever tried WireGuard, and I was playing around with it last night, it's very easy to mess up the NAT rules. There's a lot you have to think about, including the IPAM, and it might be worth it. It's definitely better than IPsec in terms of usability. Inlets, HTTP or TCP. Those are your two options. And then we're looking at securing service-to-service connections between clusters or perhaps private public clusters, it doesn't matter. Your tunnels can be public if you want. It's cloud native. You can have a Kubernetes load balancer. All the tooling for around it is open source, and you can just run it wherever you need to. Now, when we look at SASE, like ngrok, I'm a big fan of ngrok. I use it quite a lot, but it was often blocked wherever I worked and with clients. The free version limits you to 60 connections per minute. If you pay, that's only up to 260, so you can't really use that for clients. The URL, unless you, again, register, changes after 7 hours. But don't get me wrong, it's a very useful tool for just a quick fire and forget. No private tunnels with this, no Kubernetes integration, but they're doing a great job, and if it's useful to you, carry on using it. Now, the other one is Cloudflare Argo, and actually really think they're doing a great job here. There's an Edge CDN, so I can get that Raspberry Pi I showed you and have, single-digit latency in Japan. I can't think of any other way of doing that. I wouldn't want to manage all the infrastructure for that. They'll do it for me. They create a tunnel to all their edge locations. As long as I am a customer of theirs, I use their DNS and their ingress controller. I can't use things like Ingress Engine X here. I can't expose things like MySQL as far as I'm aware. And, there's no private tunnels. So we can't really use it for the hybrid cloud, multi-cloud use case. Now, Inlets itself, it doesn't have this rate limiting. You probably should put something in place just to prevent abuse, but it's not there by default because it's self-hosted. It means you decide the limits. Now, you can also use whatever ingress controller you want. You can use cert-manager. You can even have a load balancer in your Kubernetes cluster, or just deploy plain YAML pods. That also means you can use your own DNS. You don't have to rely on, let's say, like the Cloudflare one, and public and private is a choice that you can make. So back to the use cases, and this is where I think it gets quite interesting. Tobias Brunner from Fission AG over in Switzerland, he says, we offer managed Kubernetes to regulated institutions in Switzerland. Our customers' VPCs do not allow incoming connections. We want to manage them, we want to manage their OpenShift clusters. Now, regulated institutions in Switzerland, that sounds a little bit James Bond to me, and maybe it is. Regulated institution sounds a lot like banking. I don't know what you think to that. So have a look at this diagram. On the left, we've got Bank 1 and Bank 2. They both have a private VPC with OpenShift and its API server. Okay, no way into that. But if you remember the diagram I showed you with GitHub, we found a way around it. We run the Inlets client inside the private VPC, punch back to a SaaS control plane using cert-manager to provide TLS certificates for our WebSocket, so we're all good and encrypted. And then from within the cluster, the customer portal, let's say it's written in Node.js, can just talk to the Kubernetes service, and it will be like it was actually in Bank 1's cluster. You won't know the difference. And so this is something that is already being used in enterprise, in really restricted environments. And I think this is kind of an interesting model for SaaS companies. Imagine that you're kind of a CodeFresh or Circle CI. You've built this great SaaS platform, you run jobs for people, but then actually you need to just poke in from time to time and actually run something on one of their runners or fire off an end-to-end test and get a result back. This might be an option for you. Now, the other one that I sort of alluded to this earlier was, let's say you've got a legacy hypervisor, I don't know, Hyper-V, VMware. You've got a Windows VM there, and it's running MS SQL, so it's not, this is the really old version. It's about as far away from cloud native as you're going to get, but it exposes TCP on 1433. Okay, it may have auth, it may not. It may use TLS, it may not. What we do is we set up a Kubernetes cluster with a load balancer, run Engine X there maybe, or Caddy. cert-manager gets us a TLS cert for the WebSocket, and then our data flows over that WebSocket to the back end, and our monthly report just happens to be written in Node. Something on the other end of the spectrum can talk to that service as if it was really there, query it, get the data it needs. And this is a way that we can present a hybrid cloud to customers and clients in a very easy way. Right? You don't have to think about IPAM. You just have a basic ACL of what you can talk to. You set up an auth token. You run a pod. You're pretty much there. Okay. So let's do a demo. This demo is the first one you're going to see. And we're going to build a registry because apparently that just happens to be what everyone's doing right now. Now, this is where we talk about the use case where you're on your own computer. I'm going to run a bunch of commands using Arcade. What is effectively happening is I'm going to install the inlets operator I mentioned. I'm going to install cert-manager and ingress nginx. This gives me my tunnel, my load balancer. This gives me certificates, and that gives me a way of getting data in. After that, I will install the Docker registry. I'm going to output the credentials into a text file. And then this is an interesting bit for me. We had this idea in Arcade that we could perhaps generate an ingress for you rather than you having to do it yourself and mess about with YAML. So this just creates an ingress record for me, and we're going to do it on my domain. It's going to be reg. Okay. Now in the meantime, let's have a look and see if we've got a public IP yet. Still pending. Let's see if our deployment of the inlets operator is good. Looks happy. It's gone off and provisioned us a VM on DigitalOcean. It has got the IP back now, so we should be able to see what that is. And I want to ask you, have you ever seen a load balancer come up that quickly on any cloud? I think the answer is probably no. So, right, our ingress should be in place now. Let's have a look for that. Yeah, we got that. But it's not going to work yet until we set up a DNS record. This is using HTTP 01. Let me see. Teach me. Okay, so I've created, I'm going to create a DNS record for that now. And hopefully the time to live will be short. cert-manager will see it, and it will give us what we're after. Let's see. We want to see the certs. Not quite ready yet, but we should see that if we ping our domain, that our IP is there. Is that the right one? It's the wrong one. Let's give it another go. Domain create IP address. Another go. And this time I'm going to type it in manually just because I want to trust it. Okay. Let's see how our certificate does. It might take a few moments, but once that's up and running, effectively we've already got a load balancer for Nginx. We're already going to be receiving traffic on that IP. It's just now down for that DNS record to be propagated, for cert-manager to do its thing with the challenge, to issue the cert, Nginx to reload it, and at that point we can run Docker login with the domain, we can tag an image and push it, including the authentication, and we can then say goodbye to GitHub or goodbye to the Docker Hub, and we've got our own hosted solution. Now that would also work with things like Harbor, right? There's no need to necessarily use the open source solution. These commands are also on a blog post. You can find that later on. Well, this is one that I eventually got working. It was Johan Siebens, a guy from the community that put this together. And the idea was federated Prometheus. This is your multi-cloud. So here we've got AWS at the top. Maybe we're using burstable instances that are a bit cheaper, or spot instances. Below, we've got Packet with bare metal, high performance, high cost. And we want to sort of blend the two. Maybe we're running OpenFAS, maybe we're running a customer's site. But how do we do that? Well, it turns out Prometheus has a federation feature, and it's just a case of scraping Prometheus. So Prometheus on the right-hand side happens to be on GCP, scrapes Prometheus on the other side, brings all the network metrics together, aggregates them in one place. From there, you can use Grafana to view the data, set up alerts, and it's all relatively simple. Now, I can actually show you that because that's one that I did prepare earlier. If I switch into context for it, and then I port forward back the Prometheus that I'm running on the middle cluster, we can go ahead and here we are. Now, under the status, we've got our targets. One of them happens to be down at the moment, the other one's up as we're reloading. And we see inlets Prometheus packet. So that's been scraping data from there. These are all the pods it brings back. So you can actually say what you want to bring back. You don't have to just be lumbered with the whole lot. And then I believe under service discovery again, we'll see the 2 clusters that have been discovered and what their IPs are. And these IPs are that virtual inlet service that's running inside the cluster. From there, we can click on the graph, and I've actually deployed OpenVAS in both of those clusters. And what you'll see is that we have this cluster name here, app Kubernetes IO name, Prometheus packet. Again, if we make the window big enough, say let's say over the last day, we should be able to put that in our query, and then we can also put in a query about AWS, and we can see the data that's come back from that. So now we can aggregate all the data in one place. We can manage and monitor multiple clusters. Maybe that helps you out in your SaaS. Maybe it helps you out scaling across different regions. There's all sorts of things you can do there. Now, to enable this sort of use case, well, do you really want to be managing the customizing the YAML and deploying the clients, deploying the servers, setting the tokens? I think if you've got a few, maybe you do. But when you start to get to the point where actually you've got hundreds, if not thousands of these clients, and they all need their pod on the other side, and they all need to go through cert-manager, they're either exposed publicly or we access them from within the cluster, you need something else. And that's where Inlet's Cloud comes into it. Now, this is something that I've put together over the last few months, and basically from customer feedback that they want to manage hundreds of thousands of inlets tunnels. Okay. There's a CRD for this called exit tunnel, and there's also a CLI. The data plane and the control plane are separate. So you can have the control plane, we need to have it on all the time, and you'll be -tunnel in your domain. The data plane you can disable if needs be. Okay. Now, this is what it looks like. We've got list, create, connect gives you a connection string for the client. Rotate will delete the password and give you a new one. And actually have 2 devices set up here. You can see them on the screenshot. They're right behind me down there. And they're connected right now. So if I run the CLI and list, let's get into the right cluster, all of my clusters. This shows me what I've got there now. We've got the Prometheus and packet from earlier from our federation. We've got sensor 1. Okay, let's try out sensor 1. And it's giving me some data back. One of the readings is the red value. The sensor's not actually on right now, so we're getting that feedback. The other one I've got there is the LED 2. But actually, I think in my data it says LED. And so if I open this, it's not connected to anything yet. To create a tunnel, it's simply a case of running create LED 1, created, and then running connect LED 1 in the domain. And there we are. Now, Alistair, I guess you're going to hear this a little bit later after I say it, but do you want to create one of your own tunnels and connect it? Now you can see over on my, if I can get into my LED 1, yes I can. I've got a Python app that turns out it's already running. I'm now going to run my tunnel given the string I was provided with, and we can now see it. We can turn it on, and we refresh the sensor, look at the red value, because it's a red light. In theory, well, it's not actually come on, but in theory, it would have actually just put that on for us. So there's a full end-to-end demo. Future plans include potentially being able to use a REST API with this, being able to manage it in one place, get metrics, scale it down to 0, because running thousands of pods, as we know, is probably going to be exhaust some limits in Kubernetes at some point. Now let me see if I can get onto Alistair's tunnel that he's just created, just there. And he's got a version of the Inlets website. He's been helping us add a blog on there. So thank you, Alistair. Now I did indulge a little bit too much with that demo, but hopefully you found it interesting. And Marta will let me off. If you want to look like me and have this swag, you can get it on the store if you didn't tweet. If you made an amazing tweet, I'll go and look at these later. Hopefully be able to send you one for free. There's lots of tutorials, docs.inlets.dev. They've got Slack as well. Recap, you can connect services and clusters with Inlets. There's a free open source version, does a lot of stuff for you, but you might need to do a bit more work. There's a pro version with commercial support and help if you need it that does TCP as well. And then these are the automation tools that I mentioned earlier that you might want to use. So thanks for listening, and I'd be really keen to hear any questions you've got or feedback. Contact me, alex@openpath.com.
Thank you very much, Alex. I have 2 questions in the chat. I propose you answer those in the chat because we are running out of time, and our next speaker is already lining up, which will actually be 45 minutes full of questions. So if you have anything to ask the Let's Encrypt people, see you soon. Thank you very much.
Great, thank you.
Welcome back, everybody. The next speaker is just us, with the director at Let's Encrypt. If you don't know Let's Encrypt, I wonder what you're doing in this meetup. So Let's Encrypt started back in 2015, and when I got my invite to be part of their private beta, I literally danced of happiness. So Let's Encrypt really made something in my life. I really love these people, and I'm so glad to have them here with us today. Hello, Josh.
Hi, thanks for having me. Can you hear me all right?
We can hear you all right. So
Great. Well,
you are
it's
probably
nice to
the
be
reason
here.
for my X509 addiction. How do you feel about that?
Well, first off, I apologize. But it's great to be here. You built some really great stuff with cert-manager. You know, it's one thing to operate a CA, but we need software out there to make it really easy for people to fit into their software stacks and just make certificate management as transparent as possible. It seems like you're doing a great job. So thank you.
Thank you. So this is a Q&A session. Josh, do you want to first give like a short introduction to the people? What is Let's Encrypt, how it started, what are you up to? And then people, if you have questions, you can put it in the YouTube chat, which is on that side, no, that side of the screen. So post it there. I will be taking questions there, and we'll be asking them to Josh.
Thank you. So as Marta said, Let's Encrypt is a certificate authority. We're a nonprofit certificate authority, so we do not charge for our services. and we try to make them as easy to use as possible. And the reason we do all of this is that we want to secure the web. So we want to get the web to 100% HTTPS. And when I was at my last job, I spent a lot of time trying to think about how to encrypt the entire web. And when I talked to people about why their websites weren't encrypted, one of the most common answers I got was getting certificates and managing them is too difficult. They either cost too much money or it's just too much of a pain to go through the process to get them. So we thought that one of the best things that we could do to try to encrypt the entire web is make a new certificate authority that removes all those barriers. No charging money, make it as easy to use as possible, an API that can be accessed through software that just handles everything for you. And in an ideal world, you don't even really need to know about Let's Encrypt. You don't need to know that you have certificates. In an ideal world, the software just gets all this stuff for you and manages it. So we want to be as transparent as possible in your work every day so that it is just a no-brainer for you to turn on HTTPS for everything that you do. So we started in 2015. We started issuing certificates in 2015. Now we're serving more than 225 million websites. We're doing that with issuing a little under 2 million certificates per day. And yeah, our goal is to get to 100% encrypted web and stay there. So what else can I tell you?
That sounds awesome. I already have a nice question in the chat. So currently, Let's Encrypt issues certificates that are valid for 3 months. And people apparently find cert-manager so easy to use, they wonder why 3 months and not 1 week, because the automation works so well.
That's a great question. So when we started, most certificates were a year or more, and we wanted to move that down for security reasons. So for people who don't know, when revocation doesn't work very well when you have a problem with your certificate, or more specifically, when you accidentally expose your public key or your private key and have some sort of security incident. You're supposed to revoke your certificate, but that doesn't actually work that well. It might not be effective for everybody who's visiting your site. The only thing that really ends the life of a certificate is its expiration date. So instead of relying on revocation to remove a certificate from the ecosystem, we just want to have short certificate lifetimes so that they expire rather than be revoked. So this is a great question about why isn't it even less? So at the time when we did 90 days, pretty short compared to what people were used to. And we kind of got a lot of flack for it because I think people weren't used to the idea that if things are automated, then it really doesn't matter what the lifetime is. But now I think people are more used to that and starting to ask this question of why not shorter. There are a few different answers to that. One answer is that it's a bunch of work. So for us, having one certificate lifetime, and we know that all certificate lifetimes are like that, is sort of a nice assumption to be able to make. And if we want to add another certificate lifetime, we have to do some work on our end. That's not the end of the world. We're already starting to plan out that work. The next question is, how low can we go? There starts to become some limits at the lower end of this. So you run up against certain regulatory requirements, things related to OCSP responses. I don't know how low we're ultimately going to go. I would hope that we will start issuing certificates that are valid for between 7 and 10 days within the next year or two, but it is hard to say. I hope that's helpful.
One follow-up question. Will you be able to make it configurable for users if they still want 90 days or if they want 7 days? Is there an option to let users ask for specific validity?
We haven't made any final decisions about this, but what I think is going to happen is you're not going to be able to choose any lifetime you want. We'll offer a certain number of choices, so you'll be able to choose something like 90 days, 30 days, or 7 days. I don't know that those are the exact choices they'll be offered, but I don't think it will be entirely user configurable where you can pick anything. We'll probably offer 2 or 3 choices.
Sounds good. If you have any more questions, please drop them in the chat. I had a few ones which I received before today. So, cert-manager cost you some trouble, I think, a year ago, more than a year ago, I remember myself getting an email to replace my cert-manager. It was 3.4.8, I think. Do you know more about what happened there?
Yeah, so for a while, unfortunately, we have this list of clients that send us too much traffic. And for a while, cert-manager was occupying most of the top 25 clients doing that. And I think there are a few different bugs involved, and I'm not really prepared to say what each one of those bugs were, but I can say that there were a couple different categories of bugs contributing to the problem. One was that cert-manager wasn't storing enough state locally. So it wouldn't keep track of its interaction with Let's Encrypt. It would just go back to Let's Encrypt every single time it wanted to know something. So for example, if there was a failure, instead of keeping track of its own failures or triggering some kind of error that might help you figure out what's wrong, it would just keep asking Let's Encrypt over and over and over again for a cert under failure conditions. And so anytime something was broken with a cert-manager install, you might just get it repeatedly asking us for certs again and again and again. So that was part of the problem. Then I think, I think pretty much everything falls under that category. It just was not keeping track of local state and was constantly checking with Let's Encrypt for things that it should have already known about, if that makes sense. But in more recent versions of cert-manager, that is not a problem. Every once in a while something pops up, but I think we're not seeing major issues there anymore. I guess one thing I can add is that there's sort of this idea in Kubernetes, in the Kubernetes ecosystem in general, that you don't want to store state. But when you don't store the state of things on your side, you can end up sending a lot of traffic to external services because you're essentially treating them as the place where you store state. Does that make sense?
That sounds good. So in the intro talk I mentioned Let's Encrypt's changing root CAs. Can you tell us more about the changes that are happening there on September 29th?
Sure. We've got a few different changes that are happening with our roots of trust. So I'm just going to start from the beginning here. When we started Let's Encrypt, we made our own root. It's called ISRG root X1. But nobody trusted that root, so it didn't make sense, it wasn't helpful for us. So we got a cross signature from an organization called IdenTrust. So since the beginning, we've been entrusted via IdenTrust. So your browser doesn't really trust, well, your browser probably does trust Let's Encrypt now, but in the beginning, your browser didn't really trust Let's Encrypt. It trusted us because we were cross-signed by IdenTrust, and your browser did trust IdenTrust. But now the Let's Encrypt root X1 has been propagated widely enough, and your browser probably does trust it. So we don't really need the IdenTrust cross-sign anymore. So next year, that's going to go away sometime in September, I believe. So by September of next year, everybody is going to need to be chaining directly to the ISRG root and not the IdenTrust root. This is good for us in that we do not have the added complexity of a cross-signature from another organization. So for us, that puts more administrative burden on us. It makes the chain of trust more complicated. So that's going to go away, and that's good. Part of the thing that is tricky, though, is that the IdenTrust root is more widely trusted than our root. Our root is pretty widely trusted, but when it comes to things like especially really old versions of Android, there's still a bunch of, very old versions of Android that are out there in the world that don't trust the Let's Encrypt root directly. So that's the thing that we are most concerned about, but I think for most people that's not going to be a huge issue, but we are paying close attention to it. So that's what's happening with transitioning away from a cross-sign and into using our own root X1 directly. The other thing that's happening is that root X1 is an RSA root, so it uses RSA cryptography. Last week, actually, we generated a new root called root X2, and that's an ECDSA root. And we generated some new intermediate certificates for ECDSA as well. And the advantage here is that ECDSA ECDSA is computationally more efficient, so it's a little bit faster when it comes to computation, but also the size of the certificates are smaller. So if you're using ECDSA, you're going to have a little bit faster experience computationally, but you're also going to be sending less data over the network in a handshake because the certificates are smaller. And in the end, you're getting roughly the same or better level of security. So we're pretty excited about being able to offer that. And even though our root X2 is a new root, and again, not widely trusted directly, it has been cross-signed by our first root, root X1. So you should be able to use it relatively soon for anything that you could use root X1 for. And those are the big changes. So that's a big deal for us to have generated the new ECDSA roots, because the key ceremonies that go involved in generating these things are very complicated and tedious to make sure that we get every little detail right and we do it all very securely. So we did that last week. It went really well, and pretty excited about that.
Congratulations on the new root. I got a follow-up question from the chat, which is why not ED and then the number 255119, which is a nice name to pronounce.
So I am not an expert on this issue. I can tell you why I think we did not choose that algorithm. I believe the reason we didn't choose that algorithm has to do with compatibility with browsers and clients and other devices. So when we're choosing what cryptography to use for our root and intermediate certificates, first of all, we have to pick things that work with our hardware at Let's Encrypt. So private keys and all these things are generated on what's called HSMs, or hardware security modules. They're basically just special computers that protect private keys. So we need those devices to support whatever we're going to use. And then we need to be confident that browsers and all the other kinds of clients out there have broad enough support for whatever we pick. And I believe the reason that we didn't ultimately pick, I think it's 25519, is that compatibility is not where we would like it to be. Again, I am not an engineer at Let's Encrypt, so I might not be 100% on with that answer, but I'm pretty sure that's the right answer.
If there is a Let's Encrypt engineer in the chat, please shout now. So I have a next question. Let me try to ask them in order here. So do you see yourself replacing enterprise certificate authorities in the future?
And that's certainly not our goal. We offer a pretty specific service. We offer DV certificates, 90 days, automated. Everybody gets the same thing. There are a lot of things that other certificate authorities offer that we don't. And I think those things that they offer are very valuable to different organizations. So I think we're going to work hand in hand to encrypt the entire web. I don't think it makes any sense for Let's Encrypt to be the only CA. Like I said, they provide a lot of services and value that we don't. And sometimes people come to me from either big organizations or small, and they say, we're looking at using Let's Encrypt, here's what we want. We've just got to say, it sounds like Let's Encrypt is maybe not the right choice for you, but there are a bunch of options out there that make sense. So I think Let's Encrypt does make a lot of sense for a lot of people, but there are also a bunch of people out there who need the services provided by commercial CAs, and we're glad that they have those options. We don't see ourselves as competing with them.
Talking about other CAs, are there any efforts from Let's Encrypt or from the community to get other certificate authorities to adopt the sorry, I can't talk anymore. To adopt the ACME protocol?
Yeah. So when we made ACME originally, it was just something that we essentially made up for ourselves. So we designed it to work just for Let's Encrypt, and we didn't have a lot of other CAs as part of the conversation. But once we were up and running and we had the time and ability to do something better, we decided to go and standardize a new version of the protocol in the IETF called ACME v2. And the real reason that we did ACME v2 doesn't have so much to do with problems with ACME v1, but one of our principles is that we want the standard to be an actual standard that's built for everybody. And in the IETF, we were able to get a lot of feedback from other CAs and community members about what they would want in the protocol. So now we have Acme v2, and its whole reason for existence, basically, from my point of view, is to make the API work for more people than just Let's Encrypt. So I think the technical capability is out there, and now it's just up to CAs to choose to implement it. Obviously, we don't decide what they do. So I think there are a couple CAs out there that do implement Acme, and I have knowledge of more that are going to do it. I'm not going to put names out there, but I think it is slowly but surely gaining ground. I think you got to remember that, Let's Encrypt is a very new CA, so it's easy for us to do things like Acme because we're building everything from the ground up, and we have no legacy technology. We have no clients on old software stacks and things like that. But most of the big CAs out there, they've been around for a long time, 10, 20 years, something like that. I think a lot of them started in the 90s. And it's not easy to make huge changes like this. So, if you perceive that Acme is not being adopted as quickly as you would like, I don't think it necessarily reflects that CAs don't want to adopt Acme. It just takes time. Their CAs are built in a very different way than Let's Encrypt. And if they want to adopt Acme, it can involve some fairly complex changes to their operations.
Our next question is kind of paraphrasing Richard here. So you talked before about Let's Encrypt being the CA and you wanting to be supporting many clients. Do you have any numbers for us, like which clients are quite popular, which are the most used, and quite specifically for our audience, where is cert-manager in display?
I believe we do have that data somewhere. I don't have it around me, but I know that cert-manager is one of the more popular ones. So popularity when it comes to Let's Encrypt API usage has a lot to do with big organizations. So you can imagine that, for a long time, Google Clouds used Let's Encrypt. I'm not sure that they do anymore, but for a long time they did. Akamai uses Let's Encrypt. WordPress.com. So places like WordPress.com that host a massive number of sites, they end up being pretty dominant in statistics. So the question is not like how many actual people use a certain client. The question is what clients are being used at these organizations that host millions and millions of websites. So for some of those bigger providers, they've written their own clients, and so that it's just essentially a custom client for a certain large provider. A lot are adopting cert-manager now. Certbot from EFF is probably the most popular client among what I would call the long tail. So you've got, a lot of really large providers up here issuing millions and millions of certificates, but then you have collectively millions of small websites, with individual systems administrators and things like that. And Certbot is very popular, I believe, among that long tail. That's probably the best I can tell you today. You might be able to get more information if you want to ask that question on our community forums. Which, by the way, if anybody has any follow-up questions that we don't get to today, go ahead and ask on our community forums. There's a link right on the main page of the Let's Encrypt website. And me or our engineers, we're happy to try to answer your question.
Sounds like a great place to go. So we were talking like big clients like WordPress. I assume issuing certificates costs some money, at least in running the servers. What is the economic model behind Let's Encrypt? It's a non-profit, but how does it raise money to operate?
Yeah, so we are a non-profit, and the majority of the money that comes in comes from corporate sponsorships. So we have a corporate sponsorship program with 3 tiers. There's platinum, gold, and silver. And there are a few platinum sponsors that contribute quite a bit of money per year, and we're really thankful for that. And then there's a larger number of silver sponsors that contribute between $10,000 and $50,000 per year. So most of our money comes from this corporate sponsorship program. We also receive some money from grants, which is probably our second biggest source of funding. Our biggest grant there, for example, comes from the Ford Foundation. And then we get individual donations. So that's people going to our website and donating $10 or $100 or something like that. And that is a small but growing portion of our income. So again, most of our money comes from corporate sponsorship. And that's been really stable for us. We don't require anybody to be a sponsor to access any of our services. Anyone can use our service. They don't have to pay. They don't have to be a sponsor. But I think there's enough people out there that recognize the value that we provide, that they're willing to advocate for their companies to step up and fund. Like I said, so far that's been very stable for us, and I expect that to continue. On the expenses side of things, servers and infrastructure are expensive, but by far staff are more expensive. So about 2/3 of the money that we spend goes towards staffing costs, and about 1/3 goes towards servers and infrastructure and other services that we use. And you can learn a lot more about this stuff by looking at our annual report. So if you go to let'sencrypt.org, I believe there's a link to our annual report right in the front page. And that gives you a better breakdown of how money comes in and how we spend money.
Sounds like great transparency.
But I guess one more thing I'll say about that is, these days we spend about $4 million per year. So we spend $4 million per year to serve, I think, almost 40% of websites on the web. We're, like I said, serving 225 million websites or more. So $4 million a year to do that is pretty low. So we're a very efficient organization in that respect. I think there are Fortune 500 companies that have internal PKI that cost them more than $4 million per year. So for us to encrypt huge parts of the web for $4 million a year, I think is a great value proposition. And we're really proud of that.
I got a totally unrelated question for you now. This is from the chat. Azure Key Vault has now the option to issue certificates from your colleagues DigiCert using the Acme protocol. Is there an option in the making to add Let's Encrypt as an issuer there? Not sure if you know the answer.
I don't know the answer, and if I did know, I probably would not be able to say. That's really up to Microsoft what they want to do there. But it's great that they are offering those services. I don't really care where people get their certificates. If you want to get them from Let's Encrypt, that's great, and we're happy to help you. If you want to get them somewhere else, that's awesome too. The important thing to me is that if you start a website, get a certificate from somebody and make sure you're using HTTPS.
Use HTTPS, people. Okay, I got a fun one. So you now have your own root CA. What is the dance that you have to do with security around that key? And is there a Let's Encrypt bunker where the only physical copy of this key is stored?
There is something akin to a bunker, I would say, but to give you more of the story. So I think I mentioned before that these private keys are stored on HSMs, which are basically just small computers that are have a bunch of extra security measures on them. For example, they will, I don't know what you want to call it, they have tamper security systems. If you try to physically open them or something like that, it locks the system down. So they're basically just special computers to store keys. And they come in two forms. One is, I guess, what we would refer to as an offline HSM. It's relatively small, like let's say maybe the size of a shoebox or half of a shoebox. And so our root keys are stored in these offline CAs, or offline HSMs. And then those HSMs are stored in tamper bags, and they're inside a safe, inside of many layers of security inside a building somewhere. So the root keys are stored on these HSMs. And one of the important things about HSMs is that they won't export the key to us. So we don't actually know what our root key is, and we have no way of knowing because the HSM is built such that it won't actually tell us what the key is. We just do signing operations on the HSM. So you can imagine there's this little computer somewhere in a tamper bag inside of a heavy-duty safe, inside of a secure room, inside of another secure room, inside of another secure room, inside of a building that is like earthquake proof, has 5 different power supplies and all this kind of stuff. So that's the basic gist of how we physically protect the root keys. They're offline in a safe, so you can't really hack them because they're not even plugged into power, let alone a network. And they are never plugged into a network. The other type of CA is of what we call intermediate, or the other type of HSM we call an intermediate HSM. And that's what we actually issue certificates from every day, because obviously we're not going to issue from the root because that's offline. But the intermediates are essentially just rack-mounted, network-attached HSMs, and they have our intermediate keys on them, and that's what we sign with. And they can do, thousands of signing operations per second. They can do high volume, whereas the root HSMs, they do like 5 signatures per second because they're not really made for volume issuance. So those intermediate HSMs are in a rack in a secure room in a building. And then we have very secure off-site storage for backups of this stuff, both secure from people and secure from environmental issues. I think that's about as many details as I can give you.
Yeah, the HSMs are very interesting for the people in the chat room. I have 2 follow-up questions on those. If you can or may not answer, just please say so. Is there a backup HSM in case the one in the safe goes bust?
Yes. There are at least 3 copies in at least 2 different locations. I don't think I can be more specific than that, but yes, there are at least 3 copies, and they are in multiple locations in case one location were to have a major problem.
One more HSM question. Is this an off-the-shelf thing you use? Is it custom built? Can I go buy one in the store tomorrow?
So HSM as a broad term can be applied to a lot of things. Like, in a way, if you've heard of a YubiKey, it's kind of an HSM. It's the same deal where it's sort of a special computer that, you have cryptographic keys on and you can sign or authenticate with them, but you can't actually get them off it. So obviously we're not talking about something along the lines of a YubiKey. We're talking about commercial HSMs. We do use off-the-shelf HSMs. It's not something custom that we built. There are only 2 or 3 major providers of these things, and they are pretty expensive. So I don't think you could walk into a store and buy one of these things. I don't think I've ever seen one in a store. But you could just call up an enterprise sales reseller and ask for one of these, and then they would put together a quote and ship it out to you. They are not cheap. Just giving you a ballpark without specific things, I would say, the smaller offline ones are probably in the ballpark of $10,000, and the network attached ones can be $30,000 to $50,000 per HSM, and then you've got support contracts on top of that. So they are not cheap, and they are not easily available in the store, but they are off the shelf, and you can buy them and order them. Yeah.
Yeah, I wish I made enough money to buy one, but I'll just keep using my YubiKey.
Yeah, I don't know if you actually want that. It would probably seem fun to begin with, and then you realize how much work it is to manage these things.
I'll just use shorter certificates with cert-manager.
Yeah.
I have a question from YouTube here. Can you see Acme being used more widely? There has been some proposals to use Acme or something Acme-like for workload attestation for services internally in a Kubernetes or Istio cluster. Can you see Acme being used there?
I don't think I'm qualified to answer that question. I'm sure that it can be used for internal PKI services. how exactly it fits into the software you're asking about, or that kind of environment, I'm not really sure. I'm sorry.
No worries. Back to a bit more Let's Encrypt then. What is the expiry time on the intermediate certificates? Are you keeping those low also, or do you keep a longer lifetime on those?
So the longest lifetime is for the roots, and those are, I forget the exact number, but somewhere between 20 and 30 years. And the reason we feel comfortable doing that is that those are very heavily guarded keys. They are not even plugged into power. They're not online. You can't hack them. You have to physically do a lot of damage to get to those. So we're comfortable with a long lifetime there. Intermediates are online in our data center racks, and they're issuing millions of certs per day. So they're a little more exposed, right? Because they're actually plugged in. They're on infrastructure. We work really hard to protect them, but they're not as well protected as the root keys. So those have a lifetime of about 5 years. So every 5 years we replace those. And then the identity certs, because we really have no control over those, and people are doing whatever they're doing with them, those have the shortest lifetime at 90 days right now.
Continuing on certificate lifetime, so the currently cross-signing with IdenTrust, that one is gonna expire soon. You probably can still use it for the next month still with Let's Encrypt, but do you see any implications in the world of that root CA expiring? Are things gonna break?
I don't know what else is going to break. I don't know who else is using the IdenTrust root that's going to expire. You will be able to use that with us through September of next year. So it's more than next month. Next month, we are going to switch to using our own root by default, but you will have the option to continue using the Let's Encrypt cross-sign until September of next year. I think, like I said before, the biggest thing you want to think about when you're moving to our root is how much do you depend on traffic from very old versions of Android. So if a lot of your users are using old versions of Android, then you're going to want to probably stick with the IdenTrust root as long as you can. But if that's not really a problem for you, then you don't need to worry about it, and you can just switch directly to our root.
Thank you. So I've got a question from the chat again. Are you guys aware of any malicious root CAs signing certificates for normally Let's Encrypt protected domains, for example, by a state-controlled certificate authority?
I'm not aware of anything like that, no.
I think that's maybe interesting to ask some people who are monitoring the web. If you still have some questions, we still have 12 minutes of Q&A time left, so place your questions in the chat. I'll do my best to ask them. I still have one via Slack. What's the future for Let's Encrypt? Where do you see yourself going in the next 5 years?
Sure. So what we've been really busy with for the past 6 months is upgrading our infrastructure. So database capacity, HSMs, storage, networking, just generally getting ready for the next few years. So the past 6 months have been a lot of infrastructure upgrades for us. As far as features go, we are hoping to add support for IP addresses within the next 6 to 9 months. So right now you can get certificates for domains, obviously, but in a little while you'll be able to get certificates for IP addresses so that you can speak HTTPS directly with an IP address. Most people probably don't need that, but for some people it's just easier to use raw IP addresses instead of domains, and we're excited to be able to offer HTTPS support to them too. One of the other things that I want to bring up, because I think it's an interesting topic, even outside the topic of Let's Encrypt, is we're always working very hard to secure Let's Encrypt, and every year we do more and more to make it secure. And one of the big efforts we're focusing on right now is removing memory safe, or code that is not memory safe, from our infrastructure. So we're sort of looking at where are we using C and C++ in particular. So there's the Linux kernel, there's stuff like Nginx, Apache, parts of systemd. Where are we using code that is not memory safe? Because that code is relatively likely to have security vulnerabilities. So we want to get to a point where we don't really have to run very much code that's not memory safe. So we've been thinking a lot about identifying code that's written in C++ or C and getting it out of our infrastructure. And then starting to think a little bit about what is it, that's probably, if it's a good idea for us, it's probably a good idea for everybody else. So it's been interesting to look at what our options are. And yeah, we're looking forward to eliminating C and C++ from our infrastructure. But there's a lot of really critical software in the world that is still written in C and C++, even though we have a lot of evidence to back up the idea that it's just not safe. We live in a world where when somebody says, let's spin up a reverse proxy, a good engineer will say, yeah, I'll go and I'll spin up Nginx and we'll take care of it. But what you're doing when you do something like that, whether it's Nginx or anything else, I don't mean to pick on Nginx too much, you're spinning up, 3 million lines of C code on the edge of your network to handle untrusted input. We just have mountains of evidence to know that that is not safe. So I'm looking forward to getting to a point where people recognize that that's not safe and we develop other options that people become comfortable with, so that, maybe 10 years from now, the idea of spinning up 3 million lines of C code on the edge of your network to handle network data, people would think, oh, that's a crazy thing to do. Whereas today, that's a pretty normal thing to do, but it should be a crazy thing to do. We know that it's not safe and we should stop doing it. So we're thinking a lot about that internally at Let's Encrypt, trying to get that code out of our infrastructure. And we hope others are thinking about it too.
That's great. I got two final questions on this one. What will you be replacing it? I got a Rust fan in the room. Will it be Rust? Will it be Go? Will it be Python? Or does it depend?
I think it depends on what's being done. There are a bunch of great memory safe options. Most of the Let's Encrypt CA is written in Go. We are big fans of Rust, although we have not used it for very much yet. I don't think we're going to go out and write our own replacement for Nginx, right? We're going to look at options that other people have written. So I don't know what we'll end up choosing. And for some things, we've already replaced them with Caddy, which is a server written in Go. For other things, we're going to need something else. So I don't know what we're going to end up doing. I think, Go, Rust, they're all great options. We'll see where it goes.
You immediately answered the second question, what to replace Nginx with. Thank you. Back to sorry.
Go ahead.
Okay. Back to the IP issuance. Are you going to block some IP ranges from there? Are you just going to accept any IP? Are you going to allow everything that ends with all of the Amazon shared IPs or something? What are the security protections there?
So this is where I'm going to have to tell you up front again that I am not one of the engineers working on this project. So take my answer here, as a rough answer. I don't believe that we're planning to block any normal public IP address ranges. We will be blocking some that are reserved for certain uses that are not the public internet, like, well-known local IPs or something like that. But I don't believe that we're planning to block any normal public IP addresses. I hope that answers the question well enough, because I don't think that I can answer it better than that right now. Again, if you want to know the details of this and talk to our engineers, the Let's Encrypt community forums are a great place to ask a question.
Thank you. I have another question back to Nginx, but I think that might be also better for the community forums. I'm going to try anyway. So if you say this is too engineering, send it to the community, please feel free. How does Caddy and then an ampersand are the Caddies and not being battle tested against Nginx way up against Nginx being written in C?
Can you repeat the question a little slower?
No worries. How does caddies and being up... It's also so weird for us, sorry. Being not as battle tested as Nginx, you'd way up. Thank you, Frederick, to admitting you've written it poorly. Let me try again. How does caddies and not being not as battle tested as Nginx weigh up against Nginx being well battle tested but written in C?
Yeah. So I think the question here is, Caddy is memory safe, but it's newer and maybe has more bugs or something, whereas Nginx is very well tested, but it's written in C. That's a great question. So we still use both. We have not replaced Nginx with Caddy. We've replaced some things with Caddy, but not everything. And part of that has to do with what you're getting at here, where, we are very confident in Nginx for certain things, and we're happy with Caddy for other things. So we have not replaced everything with Caddy. We still use Nginx for some things, and we're still looking for what we want to replace Nginx with ultimately. I think if we're talking long-term here, though, yes, Nginx is very well tested, and that's a great quality to have. But we're going to be using stuff like Nginx for the next, 50 or 100 years. This is not going to go away. And eventually somebody's going to have to rewrite something that ends up replacing Nginx. And maybe that's Caddy and maybe it's something else. But we need to get started now so that, we can start this process of quote unquote battle testing the software so that 10 years from now, we have an alternative to Apache or Nginx that is memory safe and battle tested. So I can certainly understand why people want to use Nginx because it's so well tested, even if it is written in C. But I think we also need to start putting in the effort so that we're not in the situation where we have to make a choice between battle tested and memory safe. We need both, and so we need to get started on that now. I hope that answers the question.
Certainly does to me. I'm going to send you the last question because we have 3 minutes left and I still want to say thank you in the end. Are certain parts of your code base formally verified, e.g. COC, ACTA, or verified C?
Well, we don't write C code as a matter of policy. We don't allow anyone to run. Our engineers don't write C code. I don't believe that any of our code has been formally verified. It does get audited sometimes, but what has been formally verified is the Acme protocol itself. So we funded some research done by INRIA in France, where they formally verified that the protocol was secure, and that went really well.
Thank you. So I think we're going to end this here. So thank you very much for your questions. I even learned a lot. I know a lot about Let's Encrypt, and yet I still learn today. So you were very, very helpful here. For the people watching at home, we'll be back in a few minutes with Richard Wall from Jetstack, who's going to demo to use cert-manager to issue node certificates for your Kubernetes cluster instead of service certificates. Again, a last applause for Josh here. Thank you very much.
Thank you. Keep up the good work.
Sorry, I was pressing some buttons. Welcome back. So most of you probably use cert-manager again to issue maybe a webhook in Kubernetes, but Kubernetes itself also uses TLS very heavily under the hood. And that's what Richard has been working on. Richard works with us for several years at JetStack and is an expert in Kubernetes controllers. But he was been wondering if cert-manager can help you with issuing certificates everywhere inside your cluster. How about provisioning the cluster itself? So hello, Richard.
Thanks, Marcia. Thank you for the introduction. Can you all hear me?
We can hear you fine.
Good. Okay, so yeah, I'm an engineer at JetStack, and I've been working on a project which isn't actually currently part of cert-manager, the cert-manager controller, but is one of a number of future spin-off projects where we're exploring how cert-manager might be integrated with Kubernetes and other projects in the future. The code for everything I'm going to demo today is on GitHub, and it's open source, and you can see the link on this slide that I'm presenting now. Let me start my timer. Well, so we asked ourselves, how are certificates, how are keys and certificates used inside the Kubernetes control plane? And how could we make those certificates visible to an external certificate management system? And the background to this is that JetStack have recently been acquired by Venafi, and Venafi have a product called TPP, which allows an enterprise to see all the certificates and other types of machine identities across their organization. So what would it take to make the certificates of the Kubernetes control plane visible inside that management system? The objectives are then for all of the TLS identities in a Kubernetes cluster, we want to be able to see them clearly alongside all the other certificates in our organization. We want some way to enforce a certificate policy. Maybe we want to say that only RSA certificates should be used, or a minimum key size should be used throughout our organization. And we also want to be able to see in one place certificates which may be about to expire, or which are broken in some other way. That's the overview. Well, so my experiment has been to look at a tool called Kubeadm, which you are probably all familiar with, and it's the tool created by the Kubernetes team for spinning up Kubernetes clusters. And I'll start by quickly, if I can, summarizing what it does, in particular what it does with certificates. So Kubeadm starts, first of all, it can be used to create a multi-node cluster, but the first node it brings up is the control plane node, the one running the API server, the controller manager, the scheduler, etc. And in particular, it creates certificates and keys for all of those components. You can use Kubeadm init to do all this for you, or you can, if you need to customize one of the steps in some way, you can run the individual steps using the Kubeadm init phase command. So here's an example of using Kubeadm init phase certs all, and using it to generate all the certificates and keys for the control plane components. And you can see that what it does by default is to create a self-signed CA certificate. And that CA certificate is the first thing it creates. And that CA certificate is the one used to sign all the other certificate certificates, and also for signing the client certificates used in the next phase, a phase called kubeconfig, which produces Kubernetes kubeconfig files so that the kubelet can connect to the API server, so that the scheduler can connect to the API server, etc. The API server has this self-signed CA, and when the kubelet connects to it, it checks the presented client certificate and checks that it has been signed by the self-signed CA. So you can do this right now. And if you run these two phases up front and then subsequently run kubeadm init, it will see that the certificates have been pre-created, and it will skip those phases whilst continuing with those other parts of the initialization. When you've run those two phases, you end up with a directory tree, something like this, containing a bunch of kubeconfig files, a bunch of private keys, and a bunch of signed certificates. So there at this stage, we've brought up one node, the control plane node. Next, if it's a multi-node cluster, kubeadm will start a kubelet on each of the worker nodes, and it will give each of those kubelet processes a bootstrap token. This isn't a certificate-based authentication, it's a token-based authentication, which gives the kubelet just enough privilege to connect to the API server and for it only to request, to make a request for a Kubernetes certificate signing request. So the Kubernetes API has built into it something called a certificate signing request. And it looks like this. You can see for yourself if you use kubectl explain on a cluster. And this API has been in Kubernetes for quite some time, but there's a recent effort to bring this API towards a V1 stable version. I think it has reached that in Kubernetes 1.19. Well, a certificate signing request has a few fields on it, notably most importantly, the certificate, the PEM encoded, base64 encoded request itself, containing the template of the certificate that is required. It also has a field called signer name, and it has a username field. The signer name is a way for this API to be used both for internal Kubernetes certificates and so that it can be used extensively and by Kubernetes, by components other than the control plane components. The signer name can be a controller watching for certificate signing requests can be configured to operate only on certificate signing requests which have a particular signer name value. And we'll come to that in the demo in a moment. So here on this slide, I've just quickly taken a snapshot of the CSR certificate signing request resources that are present in the cluster immediately after a two-node cluster has been initialized. And you can see that there's one for the control plane and there's another one for the worker node. So that's how kubeadm works normally. That's probably how you've seen it work. So the question was, how would I use kubeadm so that rather than creating a self-signed certificate authority, it would instead allow me the opportunity to sign those certificates using some external certificate authority. So there are two steps that this is a work in progress, but the two steps that I've figured out so far are how to pre-sign the control plane certificates and then subsequently how to dynamically sign the certificate signing requests created by the kubelets. So the pre-signing of certificates was always possible, but it was somewhat fiddly. There has for quite a while been a mode of operation in Kubernetes where you can have it create certificate signing. Now I have to differentiate between certificate signing requests as in the Kubernetes API object and certificate signing requests as in the X509 bundles. Well, what you can do, what you've always been able to do is to use Kubernetes to create those X509 certificate signing requests. But it was fiddly and it didn't work quite correctly. So I've done some work recently to make this easier. And what I've done is created a new subcommand in Kubernetes called Kubernetes alpha cert generate CSR. And this is a simple way to create all of the private keys and accompanying certificate signing request X509 files for all of those keys. And when you run it, you get a tree of files, something like this, similar to what we saw earlier, but instead of a signed certificate, you get a CSR file. So that takes care of that. Well, it takes care of it insofar as you've got certificate signing requests, which you can then manually take to your external CA, arrange for them to be signed, and then put in place the signed certificates. And I'll show you in a minute how we've made that a little bit easier. The next part was that we needed a component which would be able to be able to watch for the Kubernetes API certificate signing requests, those created by the kubelet. And to do that these days is fairly straightforward using a library, a framework called controller runtime. A controller runtime project allows you to, well, makes it very easy for you to write a controller which watches a particular API type, and your entry point is something called the reconcile function, which is supplied with the namespace name of a particular Kubernetes API object, and you take steps to bring that to reconcile that object to, in this case, take the certificate signing request, send it off to the verified TPP server, and then go back to this TPP server sometime later and download the signed certificate. So with a controller like that, you then have to disable the built-in sign controller, and you do that with a little patch to the controller manager, disabling the built-in CSR signing mechanism. Okay, I think I'm running out of time, so I'll quickly try and show you the demo. This is all available online on the GitHub repository for you to play with and to view the demo yourselves. So let me switch screen. Hopefully this won't take more than 2 minutes. Oh, I'm sorry, I'm getting prompts from Marcia that I've got longer than I thought. I misheard her first time. So let me explain what's going on here. We've got in the right-hand pane a tree view of the certificates and the signing requests as they're being created. So the script that I've just run ran Kubernetes alpha cert generate CSRs. It generated keys and CSR files, and then those are now being sent off to the Venafi TPP server. And the TPP server is busy signing those, and we're now picking up the signed certificates. And you can see them appearing in the right-hand frame. Once all those are in place, we set up, we modify the kubeconfig files, injecting in the signed certificate data. And those certificates and kubeconfig files get mounted into a kind cluster as it boots up. The kind cluster starts by running the establishing and running the control plane components on the control plane node. And once that's up and running and the API server is available, we are then in a position to deploy this controller runtime based signer onto the control plane node, at which point it will be able to reconcile the certificate signing requests that are created by the worker node, which joins. So we can see that customize is waiting for the my signer controller to be deployed. And any moment now, it should become available. Yep. And now it immediately sees certificate signing requests in the API server, and it goes through a couple of loops, submitting them to TPP, the Venafi certificate management system, and retrieving them from TPP. Once they're retrieved, they're placed in the status field of the Kubernetes CSR objects. And once they're in the status field of the CSR objects, the kubelet is able to retrieve the certificate, and it takes care of putting that signed certificate in the right place. And it then is able to complete its joining sequence. And I exited too early. This script was designed for recording an ASCII cinema demo, but and it's cleaned up the cluster already. But at that point, you would have been able to log into the cluster and see that the kubelet certificates and all the control plane certificates were signed by the Venafi external CA. One or two other things I should mention. I've documented, if anyone's interested in following this process, the script is really an automated way of running this sequence of steps, which I've described in the repository. But here I've written some narrative around the setting up of Venafi TPP, and you could translate that if you wanted to whatever certificate management platform you're using. And I've added some narrative around each of the steps that the script performs, explaining in some detail the reasons why we run things in particular order and how the various steps interact. At that point, I think, Marsha, I'm going to finish and invite any questions, or else thanks for your time, and I'm looking forward to the next talk.
You will be in the next talk. So currently there are no questions in the chat room except one, where to find all this code, which we just sent a link to.
I'm sorry, I can't hear you very well.
Oh, sorry, I forgot to open the channel back to you. So there are no questions at the moment, except one, which is where to find this, which we posted the link in the site. So it's all in our cert-manager organization on GitHub. You can find the signer Venafi, it's called, I think.
Yeah, it's on the screen, if you're still showing my screen.
Now I am. So here you go, Alex. Alex also has a second question. Have you ever tried using REST APIs for the CSRs?
I'm trying to think what that means. I'm not sure I understand the question, Alex, and I can't see the chat at the moment. Marsha, can you shed any light?
So client Go to access the CSR API.
Oh, okay. Well, we're we are kind of we're using client Go to access the CSR API in this controller, if that's what you mean. So like all the other API types, I believe that client Go contains a generated client set for this API and a generated set of informers and listers. And I think controller runtime uses the unstructured API, in fact. I think what it doesn't do, I think there is one thing it doesn't do is allow access to the approval sub-resource. So I haven't talked about this, but there's another step to the CSR signing process. When a CSR API object is created, it has to be approved before it's signed. And that is, in this demo, handled by the built-in controller, the controller built into Kubernetes. But equally, that could be managed by an external process. And we're looking into that as another cert-manager side project. But that does require access to a particular sub-resource, the approval sub-resource, similar to a status sub-resource. But I don't think that's there yet. The person who would know is James Munnelly. He might be busy answering that question on YouTube.
Well, that's the next speaker. So thank you very much, Richard. We'll be back in a second here with our last hour of amazing talks, which is 2 talks, which is an AMA with all cert-manager maintainers, which includes Richard also, and then also a talk from the render people about how they use cert-manager. Be back in a second. Be sure if you have any questions for the maintainers of cert-manager, anything for us, post it in the chat, and I still need to learn to point out the right side, that side. See you in a second. Hello again. This time I'm welcomed by a lot of awesome maintainers. We have James Munnelly, Richard Wall, which you saw before, and Josh again. Guys, do you mind introducing yourself for a second? James, you go first.
Yeah. Hey everyone. I'm James Munnelly. So I started the cert-manager project about 3 years ago or so now, whilst I was working at JetStack. And yeah, I'm here to answer any questions you've got.
Thank you. Richard.
Well, hello again. Yeah, Richard Wall, and I've been at JetStack for about 4 years, I think, working on various operators for Cassandra databases and etcd databases, and now most recently I've joined the cert-manager team, helping James and Josh.
Thank you.
And Marsha, sorry.
Oh, and Jake, don't forget Jake.
Right, yeah.
Yeah, hi everyone, I'm Josh. So I'm a customer reliability engineer at JetStack. Been at JetStack for about 3 years, or over 3 years. One of the years as an intern. The the rest full time. Worked quite a few things at JetStack. So Tarmac way back in the day, Kubernetes proxy, version checker, and yeah, of course, cert-manager, and bits around cert-manager like the CSI driver and things like that. Probably forgetting some things, but yeah. Marsha?
I already introduced yourself at the beginning, but you missed that part. Hi, I'm Marsha. I'm working full-time at I'm working 80% at JetStack on the cert-manager team, and for 20% I am also a teacher. I actually have way too many jobs, but the one I like most is working as cert-manager. So I already got one question from the chat room is, where do I find that music? Which I think is a question for me. So this is all royalty-free music that you can find in the YouTube room, the royalty-free music library. If you Google that, you will find it. It's all open source. Okay, thank you. So I already have a question for you all, which I am afraid to ask. What is your favorite page of RFC 8555?
I have to ask you to give me a reference on them, because I think you've got the whole RFC printed out, right? And bound.
I have it. It's over there in the corner.
Oh.
Okay, serious question now. This is one for you, James, specifically. Why did you start cert-manager in the first place?
Yeah, I think that's a good question. I think it was kind of a combination of things. So as Matt mentioned in his kind of intro earlier today, there was actually a precursor to cert-manager, which was kubelego. Some of you may have used it or heard of it at least. It was very focused on Let's Encrypt at the time. The actual name of the project comes from, like the Lego part, comes from the name of an Acme library that it used to use under the hood. And that was started by Christian Simon, who previously worked at JetStack with me as well. And it, again, was a very, very popular project. As Marsha said, Let's Encrypt was kind of the origins of all of this, certainly, and it's kind of one of the biggest use cases of it still today. And I think at a similar time, I was also looking into building something similar to kubelego, because Let's Encrypt had come about. I heard about it and was getting fed up of finding certificate services where you could get certificates for free. I remember there was one, I can't remember what it's called now. It had a pretty janky user interface and I had to authenticate with client certificates.
Didn't it happen to be Start SSL?
I think it was, yeah. Yeah, so I was very excited as well about Let's Encrypt, and it was at the same time as I was getting started with Kubernetes, and third-party resources kind of came about. So after kubelego was started, I soon after that joined JetStack as well, and kind of at the same time, third-party resources came about, and I started to think, well, we could kind of reinvent some of this around third-party resources. So if you go back to the very first commit in cert-manager now, you'll see that the certificate resource that you're probably all used to today actually explicitly calls out Acme configuration, and that actually stuck with the project until I think 0.11, and that was what most people know today as the V1 Alpha 1 API, where you'd specify certificate.spec.acme. And so even cert-manager was rooted in Let's Encrypt. But I think, I haven't actually looked it up, but a few commits later, we introduced the issuer resource, and it started to become apparent that there is more out there, first of all, than Let's Encrypt. But then also, there's actually a lot of, like even with kubelego, people were configuring staging deployments of kubelego that pointed at the staging Acme instance, and then having to upgrade or switch over to the production endpoint. And that was definitely a pain point for users. And so the idea of being able to actually manage an Acme account with an issuer sort of came about there. So yeah, I from a technical perspective, I think that's kind of where cert-manager came from. But in terms of like what actually gave me the idea, I've got a server running at home, and honestly wanted to get certificates for it there. Through engagements with customers, though, we're also seeing lots of people obviously need to manage TLS certificates. It's a common foundation of identity, and all sorts. So, yeah, I mean, I guess that's where it that's where it came about from. Just a need to sort of manage this in an automated way. CRDs came about after that, and that was kind of a big upgrade. And you could see really that the extensions to Kubernetes, that whole ecosystem, is really developing and had a lot of potential. So yeah, I don't know if Richard or Josh, I mean, you've been around, you've seen a lot of the project as well. I don't know if you've got any thoughts. Or Marshall.
Well, I've only just joined the project, but I wanted to, you were talking about, James, you were saying third-party resources. So that was the old name for custom resources, wasn't it?
Yeah. So that was kind of the first revision of it, and it didn't have anything fancy that we see today. I think it predated validating and mutating webhooks, certainly conversion. It didn't have schemas.
So it's been interesting to see like how we've been using those from the get-go, and how that system has advanced, and how you're sort of really in touch with the developers of that mechanism, right? And we've sort of been at the forefront of webhooks and conversions and such.
Yeah, I definitely agree with you that we're on the forefront of like adopting these things. And I think that's kind of partly been like where we've had troubles with upgrades, and where we've had troubles along the way. Just generally, like I feel like we've run into a lot of problems and had to report a lot of problems to the upstream projects, and that certainly helped to shape how the feature, like how it's all come about today. So it's certainly not been without its challenges. I think we'd all agree.
Okay, so next question. So this time not for James, but for Richard, Josh, and well, probably I. So let's start with Richard's. How did you get involved in the cert-manager project? When did you first hear about it? Why did you join it?
Well, I first heard about it when I joined JetStack. I mean, I think it was at the time. Well, no, when I first joined JetStack, there was Cube Lego, and that apparently was written by Christian as part of his interview for JetStack. Then I think I've been sort of helping out here and there with cert-managers since the beginning, since James created this successor to Cube Lego, cert-manager. But I've only just been involved very heavily in the project in the last 6 months. But it's really fun. It's fun to be involved in. I have never. Well, I was involved in the Navigator project, which predated controller runtime and operator SDK. And in Navigator was an operator for managing multiple types of database in Kubernetes, and it was maybe ahead of its time. But James and I worked on that, and James brought a lot of his experience of cert-manager to Navigator. I think I might be going off topic, but I remember it being a hell of a lot of work to write the reconcilers and the controllers from scratch. So it's very interesting to join cert-manager now, having written a few controller runtime based operators, and see cert-manager, because of its age, still has a lot of code written without controller runtime, and it'll be interesting for me to see how we can start to adopt controller runtime more in cert-manager. I mean, I might be jumping the gun a bit. This may not be on the roadmap, but that's what I'm quite interested in seeing.
Josh, what do you think? Well, why you joined?
Yeah, sure. So, like I said, I joined JetStack a number of years ago as an intern. So it was a summer internship at university, and then I stayed on part-time during my final year. And during that time, I was working quite a bit on internal tooling at JetStack, sort of automating some admin stuff and things like that, as well as helping out with the Tarmac project. So that was a Kubernetes provisioner for AWS, with dreams of it being sort of agnostic to any cloud provider. That ended up getting sunsetted. So the kind of natural progression was, hey, we have the cert manager thing. It's quite good. Yeah, why didn't you work on it? And no, yeah, it was great. I think that was definitely over 2 years ago, maybe. I'm not sure about the timelines, but maybe not that long. I'm not sure. But yeah, no, that's kind of how I got involved in the project. And at that time, it was just me and James. I remember having stand-ups marked for 15 minutes, turning into at some point 2 hours, and having lots of in-depth conversations about a single field on a certificate resource, and yeah, having debates on where to put things and things like that. But so yeah, that's how I got involved in the project, and obviously starting out small, as you do, and then eventually progressing on to doing things like introducing the certificate request resource. This was back when we even then had kind of intent to integrate with things like Istio, and it became clear that the certificate request back then, which was doing both the X509 certificate like templating, requesting, generating the CSR, and then going ahead and sending it off to Istio, etc. That was all kind of happening transparently in this kind of one resource, and even it was the kind of Istio integration that really kickstarted the kind of separation of the concept of having a separate certificate request resource that was kind of reconciled separately. But yeah, perhaps I'm getting ahead of myself. But yeah, that's how I got introduced to the project, and yeah, where we are today.
I'd say a massive shout out to Josh for that work on the certificate request, because I think that's been quite instrumental, not only in integrating with other projects like Istio, whatever else, but actually being able to enable other people, other companies to go and build their own integration with their own certificate management platforms or whatever issuers and CAs they've got internally, which I think has been pretty huge.
It's a pretty important part of cert-manager. To answer the question myself also, I've been using cert-manager for a long time. I even used kubelego in my previous job and on my own clusters, and I just loved it. I already had like a pre-lab for Let's Encrypt and how they worked. And then when I got fired from my last job because they went bankrupt, then suddenly Matt Bates came to me on Twitter and said, "Hi, we're hiring on Jetstack for the cert-manager team." And I was like, "Cert-manager? That's amazing." So yeah, that's how I actually came here via a stupid tweet, and I've been here for 9 months now. I just noticed, and never been happier since. So I have a question which was asked also in the Slack, but also today in YouTube. So, do you use cert-manager yourself? If so, what do you use it for, and how do you install it? Let's start with James.
Yeah, so I do use cert-manager myself. I think my server has probably been one of the first ones to install all of the dodgy updates that may have come through over the years. And yeah, the loss of service on some of my own services probably have caught a few things and triggered a prompt patch release after the .0 patch release, after a new minor. I have gone through various different ways of installing it. So I think for a while I've used Helm. For a while after that, I've switched over to kubectl. There's always been, like, I'm particularly careful around how I manage the rollout of CRDs, and then nowadays kind of webhooks too, which came up recently before upgrading the controller. So I kind of liked for a while to have a bit more control in just using kubectl. I think, as one of your other questions, I think this is from Leonard, has brought up around kind of Helm and the handling of CRDs there. That's kind of part of the reason why I did switch over to using kubectl to manage it, or to manage the CRDs specifically. I now actually use Google's Anthos config management project to manage my installation. I still separately install the CRD resources though myself using kubectl, just because I think in a lot of GitOps controllers right now, there's not any special management or complex management for CRDs and the way they get installed. I think it's a problem space ripe for some work is kind of like life cycle management of extensions to Kubernetes APIs. I've got a whole load of opinions that maybe we'll have a separate question for coming up. But yeah, anyone else? How do you use cert-manager?
Who is you? Richard.
Well, I don't use it in my hobby time, but I use it every time I deploy a controller runtime project. It's kind of bundled in to their customized scripts, and you uncomment one or two parts of the customized templates that they provide, and it takes care of. I beg your pardon. It doesn't actually take care of installing cert-manager, but it does then make use of cert-manager resources. So it's always been installing cert-manager for me has just been using Customize and kubectl to install the cert-manager full manifest, which includes the CRDs. And I was recently investigating a problem reported by one of our users, someone who was using a tool called Flux, which James Munnelly helped me a little bit with. It's somewhat similar to Anthos, I think. So that's one that I am going to be investigating shortly, because we got to the bottom of that person's problem, and it wasn't to do with Flux, but it's made me think that we ought to improve our documentation for those people installing cert-manager using GitOps style systems.
Just Richard, you kind of almost reminded me to maybe expand on some of the specific use cases of like how I use it as well. So yeah, I use Let's Encrypt, and I also manage my own internal CA, which I have scripts kind of like push those off to my network switch even. I kind of got a bit ahead of myself with the internal networking and registered a .dev domain name, which unfortunately sets a, what's it called, record. The type of record that forces you to use TLS on every single domain name, which means that my network switch, my access points, like everything with an admin interface now needs a certificate. So I've kind of forced myself to use my Kubernetes master for that. HSTS, yeah, that's it. Yeah, so that's another way I use cert-manager. And yeah, sorry, jumping in there.
No worries. Josh, do you have any switches running cert-manager?
I can't say I do. So yeah, I'm same as Richard. A lot of my hobby projects aren't necessarily TLS dependent, but indeed during my kind of day-to-day work, if it's obviously not cert-manager specific, customers and things like that, that's obviously dependent on what the customer is using. But indeed myself, if I'm doing some development work and not necessarily even cert-manager, I think the first two lines of bash I'm doing is kind of create cluster and then kubectl apply https / etc etc. So yeah, that's the way I kind of using it with kubectl, and then indeed it will be internal PKI typically for what I'm using it for, and usually the kind of self-sign trick you can do by creating a self-signed issuer which backs a CA issuer, which is I was quite a big smile on my face when I discovered that. Yeah, I think that's me really.
Thank you. So, yeah,
Can I ask? I was just going to ask. So James, that setup where you're using cert-manager to create certificates for your switches and home network, is that you should blog about that? It'd be quite interesting to read more about it.
Yeah, I made it at some point.
Not making more work for you, but
yeah. I made it at some point. Yeah, I also was thinking. I'm trying to remember now. There's something. I've got a thing that plugs into my WireGuard network as well. So,
right.
Yeah, there's a few different places. I think that's still using the old certificates API, not certificate requests directly, though.
Right.
So, how about you, Masha?
So I use it mostly to run my home Kubernetes cluster, which is sitting right over there in the rack. It's on screen. what I run on there is I once written when I was younger, about 2 years ago. I've written my own platform as a service, which has exactly one customer, and I only want exactly one customer on there, which is me. So I made this to make all my personal projects easily hostable, and that's all cert-manager powered. It mostly runs cert-manager for the external endpoint certificates using Let's Encrypt, and I think I also have a few internal ones in there, but nothing as fancy as switches yet.
So fancy. I wouldn't say it's a good thing that I have to write all this extra bash. Honestly, it's a symptom of HSTS.
I do want to use it to connect my network to the edu-roam network and have edu-roam at home.
Should petition Cisco to get native support.
I know people at Cisco. Let's start emailing. So, question, James. You often in meetings tell sorry for the confusing name cert-manager, while we all think it's a good name, but you often say that you hate it. So what would you like to rather name cert-manager 3 years later?
So, like you said, I hate it. I think it's grown on me, especially after we were talking about this earlier too. The one thing about a pragmatic name, like an actual descriptive name, is like no one doesn't know that cert-manager manages certs. You know, it is clear what it does from the name. I think like a marketing name is good. Maybe we should have, like, if at the time of it being created, JetStack actually had a marketing department, like of any significant size, someone would have stopped me before I put it out there. But I think Matt at the time, at least, always said, I don't know if he'd. Well, he probably would stick with it now. I think he likes it. But he always said that he wanted it to be, not something controlled just by the company and whatever else. So I think it's, I think it's probably grown on me. And also, don't ask me if you're going to rename it. Do not ask me again. I've already said I'm not allowed in those conversations. So I'm not even going to pass an opinion or a judgment. What would you name it?
I'm not great at those things either.
Yeah.
So I'm gonna combine a few questions in like a more generic one because we only have 10 minutes left. Where do you see the future of cert-manager? Where do you see us going? And I think that's more individual for everybody here. So James, where do you see it going?
I mean, I also want to allow some time for everyone else to speak. So I think, for me at least, I'll focus on one thing, which I think is the project kind of moving away from being just a single project to being more of like an actual ecosystem around it. So us separating out the ideas of like API definitions, but with certificate request coming along, and then actually being able to break apart even our issuer implementation. So Richard mentioned like the Signer Verify. There's also Signer CA. And I imagine like once we get, I think the intention is once we get to that point, having like Signer Acme again, and then almost having cert-manager as the umbrella that weaves these bits together, which, to me, seems like a good way for us to, first of all, introduce some kind of like discipline around different bits, but also make sure that we're not like siloing those out of tree issuer implementations and making sure that we're not kind of special casing like the internal use cases and actually kind of supporting the community to build what they need around it too. But I'm keen to hear what anyone else has got in terms of what they think.
Richard.
Well, we are talking, aren't we, about making use of that Kubernetes certificates API more and more. In particular, the Kubernetes CSR type. We can't replace the certificate request in cert-manager yet because the CSR type isn't the V1 version of the CSR type isn't widely available, isn't widely used or people aren't using modern enough Kubernetes clusters for us to be able to use that. But cert-manager, an option for cert-manager to be able to use that API rather than its built-in certificate requests might be something we're we start planning for. And also what I said before, I mean, I suppose I would quite like to investigate which parts of which controllers in cert-manager might be usefully re-implemented using controller runtime, and as following on from what James said, maybe broken out into separate components at the same time. And then we should say we've got quite a lot of plans for enterprise features, haven't we, around cert-manager? But that's a separate discussion.
Josh?
Yeah, I think for me, I think I mentioned it at the end of my talk earlier. I think the kind of ingress use case, I guess, it is like a fairly solved problem. I think that's quite stable and it's clearly widely used and people are happy with it. It is the areas around securing, Kubernetes control plane components themselves, or indeed internal PKI with service mesh, which I think is interested going into the future, and also things that I'd like to see that are kind of adjacent to this space are things like certificate policy, for example, which make these features more viable or kind of more acceptable in those kind of spaces. So yeah, that's what I'm kind of interested to see where the project goes in the future. And yeah, with the certificates API especially, the upstream one, I think we're well placed for that.
Yeah, because we've talked about that policy being, maybe that's hooked into the approval process of the certificates.
Indeed, yeah. I think the main bit is around the identity of the requester. So the Kubernetes API server enforces the identity of the request when it's created on the status, which we can rely on. But if you take in the case of our internal certificate request resource, the only way to get that reliably is through the webhook. It's extra hops, and yeah, it's obviously a cleaner implementation to leave that certificate request resource, certificate signing request. But yeah, I guess implementation details. But yeah,
I'm excited to see what more comes of things like that user info block, because I think it's quite a powerful and essential piece, really, and it will enable a lot of policy control and much more advanced. Much more advanced systems to kind of integrate where they do require that sort of thing.
I'm going to try to answer mine quickly because we only have 4 minutes left. So I'm going to go technical. These guys nailed it, everything I think about cert-manager. But I'm thinking about general Kubernetes. Right now, most Kubernetes services communicate over plain protocols inside the cluster because we see this cluster as being a trusted bubble. But I think that with marketing term would be zero trust there, to have every single Kubernetes server internally fully talking over an internal TLS connection with an internal PKI, with an internal OCSP server to 100% guarantee end-to-end that nobody's even inside your cluster can talk to your service without having a valid certificate. So I'm going to take one more question because we're running out of time and our next speaker is waiting. And this is actually a question from our next speaker. So, are there any stability guarantees for client Go versions used with the future cert-manager versions?
So, I don't mind jumping in and talking about that.
There you go for it, James.
So, yes, that's kind of exactly what I think the V1 release, the V1 API actually kind of says. So, with that, if you're depending on the V1 endpoint, in the Kubernetes REST API, you can be sure that you can always submit resources of a particular form that works today to that endpoint, and it will continue to work. That doesn't mean that when V2 comes along, you can just blindly change to using V2 with those same resources. But it does mean that you can continue to use V1 and migrate to V2 as and when you're ready, in a similar way that we've had with V1 Beta 1 to V1. In terms of the client Go packages, I think that's actually a bit of a tricky one because of the way code generation works in client Go with the code generator project. The actual, in terms of Golang compatibility, I think they don't make a strong promise about not potentially breaking that. So you could have a function name change or something similar. What I'd advise if you are depending on client Go and code generator is potentially, and you don't want to have that issue coming up, which usually is quite minor when it does happen, is to generate the like PKG client directory yourself using code generator and whatever version of like the Kubernetes dependencies that you're already using. Alternatively, the controller runtime project has the generic client in there, which actually works really well, and it will save you having to depend. Well, it will save you being locked to cert-manager's version of the Kubernetes dependencies. So yeah, I hope that answers your question. It's a complex topic, and it's difficult to sum up in what I think is probably about 30 seconds. I know I'm going to be rushed off the stage, but yeah, happy to chat as well a little bit more on the Slack and maybe put together a documentation page on exactly what this means. But you can be rest assured that there's not going to be big issues or any like wire protocol changes that might affect you.
Thank you. And actually, a self-correction here. I was wrong. The next speaker is Josh. We still have one talk in between. I was running ahead of schedule. So thank you very much, everybody. I think we still have so many questions left. I think this calls out for Community Day 2. Do you think?
Yeah, definitely up for that. And I'll try and answer, if there's any more of these questions that we haven't answered, maybe we can move them into the Slack channel and kind of answer them in threads there or something.
Great idea. So you can find us on the Kubernetes Slack in hashtag cert-manager. So thank you very much, and we'll see you in a minute for Josh again.
Thank you.
All right. Welcome back, and we have Josh next to me. That's right, next to me again. Josh wasn't finished talking today, so now Josh will talk to you about our HashiCorp vault issuer, and more specifically, how to use vaults to limit who can request which certificates. Hi, Josh.
Hi, everyone. Thanks, Marta. Yeah, hi, everyone again. Indeed, getting close to 8 o'clock, so I'll try and be quick with my talk. So I'm going to talk today about cert-manager with Vault and how we can leverage Vault's certificate policy to limit the certificates that can be signed based on the identity that has requested them. So it's kind of conjoined to what I was mentioning earlier about kind of implementing this kind of certificate policy idea, which is particularly important for your kind of internal PKI with your clusters with multi-tenants and kind of limiting bad actors and strength in depth, etc. So in this talk, I'll go through a very brief overview of how cert-manager works and how the certificate lifestyle and the flow. I'll mention the Vault issuer and how that works, and specifically with the Kubernetes service account authentication. I'll then briefly touch on certificate roles with Vault and a little demonstration on how we can leverage this Vault issuer to manage or implement certificate policy using Vault. So a brief overview of the certificate life cycle with cert-manager. So first of all, we have a certificate you're probably familiar with, and this is kind of a human friendly, readable YAML file which will describe the certificate that you'd like to be signed for you. Once created, cert-manager will then create a certificate request, which includes your X509 encoded certificate request document inside that resource that's created in the API server. Cert-manager is also watching this resource, and this will then be sent off to your configured issuer or cluster issuer, and then based upon the spec of that issuer or cluster issuer, then gets sent off to a real CA through whatever implementation that backs that. So in our case, this would be Vault, or indeed it could be your self-signed issuer, CA, Verify, etc. Once that gets signed, it then kind of goes back up the stack, and your certificate will then be stored in a secret, a Kubernetes secret, along with the private key, and then that can obviously get mounted into your pod as a kind of secret map. So next on is the Vault issuer. So there are 3 authentication methods that we support in Vault. The most important here is, of course, the service account auth that I'm going to be talking about in a moment. And this is where we can provide a Kubernetes service account that has been bound to a Vault role and use that as authentication when signing our certificate request. So in the case of the Vault issuer, we'll have our kind of Vault issuer here that will see the certificate request to get signed. That will get sent off to Vault. And in that request in behind the scenes, it's going to be using the service account JSON web token that we've referenced in that issuer spec as a header to our certificate request to Vault. Vault will then authenticate that JSON web token. It'll then it will authenticate that JSON web token based on a token review to the API server. So it's going to send it off to the API server to get some identity about the token or about the service account. And then once that's returned, it's going to map that service account identity to a Vault role, which will have some policy attached to it in the kind of Vault policy configuration. And then all being well, that's passed its kind of internal policy check, it'll go ahead and then sign that certificate using Vault's internal private key, the signing private key that's been configured, and then send that back off to the cert-manager issuer. So there's quite an exhaustive list of possibilities for Vault certificate policy. And there's, as you can see, quite a few on this list. The one we're going to be mostly focusing on today, if I can see it, is going to be allowed sans names. I can't see it. I can't see it somewhere. Anyway, it's on that list somewhere. But as you can see, there's quite an exhaustive list of policy rules that we can use. I'm using Terraform in this demo to configure Vault. I found that to be the easiest. And the way that we've set this up is we have defined some service accounts. So we're creating the service accounts through Terraform. In this case, we just have service A and service B. And they are going to live, or that's going to be the namespaces rather, more importantly. So we have service A namespace and service B namespaces. And then in our certificate policy here, we have mapped the service accounts that we've defined here into certificate policy here. And most importantly, we have allowed domains here. And what this means is the service accounts living in service A, for example, are only allowed to request certificates which would be routable through the kind of Kubernetes services. So you think about Kubernetes services, you have your kind of service.namespace as its kind of domain. It means that we can only request certificates that are valid for our namespace. And what this means is that you can have a tenant, a multi-tenanted cluster, where you have a single tenant which might have access to an entire namespace, including secrets. But the secrets that they can request using service accounts from their namespace are only valid for just their namespace. You won't have a tenant which is able to request a certificate which is valid for another namespace and potentially, cause some nastiness that way. So it's a nice way to lock down a certificate signing, but based on namespace and therefore kind of valid DNS names in your cluster, without restricting access of tenants to everything inside that namespace. So there's no need to block access to secrets, etc. It's all done on the namespace level, which is quite a powerful thing when kind of trying to enable your tenants, to have as much access as possible to kind of get their job done. So in this kind of multi-tenanted cluster setup, you'll see here we have these kind of two namespaces defined here, and our two users, Alice and Bob. They'll authenticate to their own namespace, which will have some workloads running, consuming or mounting secrets, which are produced from our cert-manager certificates. And they each have an issuer in their own namespace using a service account that's authenticating to Vault. And either when Alice or Bob create their certificates referencing this issuer, they're obviously using different service accounts in the separate namespaces, and they'll be bound to their respective roles in Vault and be matched against their own separate policy. And I'm probably running out of time, so I'll go quite quick. This is just a quick kind of demonstration on the RBAC rules for kind of each of Alice and Bob. This is for service A, for example, so that's service A namespace. I'll get to my demo. So I have a cluster running. It's got some things running it, sort of Vault, and it's got some kind of application or an application running in service A and service B. If I get issuers, for example, you can see that I've got this service A issuer running with Vault and my service B issuer, or my Vault issuer running in service B rather. So let's say for a second that I'm Alice, and I want to create this certificate. This looks fine in terms of for Alice to create. So this is in the service A namespace. You can see from the DNS names, it's creating a front end .service A certificate. So that should be fine, and that is valid for this namespace and the server. So we go ahead and create this this good cert. We should then see that if we get our certs and service A, you should find that it's fine, that got signed by Vault, and that certificate is now ready to be mounted to pods, etc. But for example, if I was to create a quote-unquote bad cert, so you can see in this example, I'm still in namespace A, but I'm creating a certificate that is valid for front-end.service B, which is indeed obviously another namespace and shouldn't be allowed to be created in service A. So go ahead and create this bad cert. And if we get our certificates, you can see this front-end bad cert is not ready. And we can get the certificate request from the namespace as well. You can see already there. So I can describe this front-end bad cert. And you can see it's quite nice. We get quite a nice error back from Vault. So a signing error, Vault failed to sign certificate. Failed to sign certificate by Vault, and it's due to a subject alternative name frontend.service B not allowed by this role. You can see that we quite cleanly kind of lock down kind of certificates that can be requested in each namespace. That's it for this demo. Here are the resources that I used. I think this is probably the most important. The kind of demo that you can find on my GitHub, and yeah, that's it. That's all from me. I don't know if there's any questions.
Thank you, Josh. Currently, there are no questions in chat room. We're also running out of time, so I propose you just answer those in YouTube itself. So
yeah, no, that makes sense.
Yep, thank you. And I'll see you all back in a few minutes for next speaker. Welcome back. We keep our best talks for last. So I manage personally 50 certificates on my server with cert-manager, which to me seems like a lot, but we found somebody who manages more than I do, namely tens of thousands of certificates, one for every website that you host at render.com. So you're up for our next speaker. Hello, Anurag. How are you?
Hi, good. How are you?
Good.
All right, so very happy to get started. I think we're using cert-manager in a fairly unique way, and we might be able to help with some scaling issues that you might have as you start adding more certs to your own infrastructure. But give me just 1 second. Let me mute the other YouTube stream I have going.
That'd be great. I was wondering what I was hearing.
Yeah, sorry. Okay.
No
okay, is this better?
Yeah, that's perfect. Thank you.
All right, so let's talk about render first, because most of you have probably not heard of render. We are some kind of a mix, I'd say, of a platform as a service and an infrastructure as a service provider. So obviously, render can do everything that something like Heroku can do, but we can do more. For example, we can give you access to block storage, and we can give you access to private networking that's built completely transparently. So once you create your account, you just have your own private network. You don't even realize it, but it just works, and you can address services by name. And there's a bunch of other features that are built to prevent migration to infrastructure as a service providers and to prevent migrations to giant DevOps teams. So our goal is to make sure that you don't have to build out a huge DevOps team and you don't have to migrate to AWS. And we make starting really easy. A little bit about the company. It was founded in early 2018. And then we launched later in 2019, launched publicly in 2019. We had been in early access for a while. And then last October, about a year ago, we won TechCrunch Disrupt Battlefield. For those of you who might have seen Silicon Valley, that's the competition. At this point, we have tens of thousands of users and websites and developers and businesses and teams, and we're growing really quickly. And most of these people on our platform, including Render itself, all the things that we use on Render, we need certificates. We need Acme certificates, and we use Let's Encrypt for it. And we could not be more thankful for the existence of both Let's Encrypt and cert-manager. We've had some really high-profile users, or we still do. The had bit applies to Pete Buttigieg, for those of you who follow American politics. He was a presidential primary candidate, and his whole campaign ran on Render, and it was really interesting to see all the spikes during the debates. But we also have established companies like Stripe, where I used to work, and the front-end end-to-end testing framework, Cypress and NYU, and other customers. If you go to render.com, you'll see some logos. Our backend is all Go and Docker and Kubernetes. We also run some stuff outside Kubernetes, and we run across multiple clouds. So we use GCP and AWS, and also a couple of other providers. And then we have regions, customer regions in the US and in Europe, and we're opening up an Asia region shortly, and that will most likely be on bare metal, but obviously none of that is visible to our users. That's mostly for performance and cost. You can probably read these tweets, and if you go search for Get Render on Twitter or just render.com on Twitter, you'll see just how much um, developers love using render, and a lot of it just comes from how easy it is to provision certificates. I mean, that's part of it, but without it, I don't think we would be as valuable to people. In fact, we can provision wildcard certs for people without managing their DNS. And I think we might be unique in that. And the only reason we can do that is because of cert-manager. So we've been issuing, or we currently have, like I said, tens of thousands of certificates. And then if you count renewals, we're just constantly hammering both cert-manager and Let's Encrypt. And we're very grateful for that. This is a little bit about our stack. So we do have everything on Let's Encrypt. Pretty much all the certificates we issue are Acme. There's almost no certificates that aren't. And then we started using cert-manager back in October 2018, and that was V 0.6.0, a long time ago. This was before the migration where you had to delete everything after taking backup, of course, and then re-import everything, and it was really painful, but we got through it, even with tens of thousands of certificates. So yeah, we've seen cert-manager evolve quite a bit over the last 2 years, and it's been amazing. It's been really great to see the community come together, and JetStack, of course, taking such good care of everything around the ecosystem and obviously the code base. And as a Go shop, it's been especially helpful because we can just dig into the code and interact with the code directly. So we don't actually create any user certificates using YAML. It's impossible to manage that kind of volume with YAML, even if we generate all of it. So all of our certs are created in our Go code using the cert-manager custom APIs, using their CRDs, and we use cert-manager, the Go module, to create these certs. And that was why I asked a question about client Go compatibility earlier. We've had some issues where cert-manager needed a specific version of client Go, and some other libraries in our code needed a different version. And given Go modules the way they are, they don't support different versions of indirect dependencies. It can become messy. But anyway, we got around that. And we don't use Helm at all. We try not to. We use static manifests for upgrading cert-manager, and we use cert-manager in a lot of clusters. There's one instance per cluster, and it has really helped us scale up our overall infrastructure in a way that allows for issuing certificates wherever we need them. The primary usage for these certificates is in our distributed load balancers in all our regions, where we load the certificates that are created in memory into the load balancers that terminate TLS. And this happens in real time. As certificates are created and issued and renewed, the load balancers reflect the latest values. And that allows us to offer our users TLS termination, obviously. And we don't use ingresses because we've had some bad experiences with ingresses. But more importantly, I think, given our scale, ingresses don't really work for what we're trying to do. Not just our scale, but also as we expand to non-HTTP services, we already have a non-HTTP load balancer that serves our Postgres offering, where you can connect to Postgres us.render.com and you access your database from outside the cluster. So ingresses don't really work for us, but cert-manager is great because you have access to all of the pretty much all of the certificate data and the secrets, and so we just load them wherever they're needed. And we'll talk a little bit about the flow on the right-hand side in a little bit. Most of our certs are HTTP/01 validations through Let's Encrypt. When our customers, obviously, when they require wildcard certificates and they need us to manage them, then we use DNS challenges with cert-manager, and they work great. And perhaps the biggest thing that cert-manager lets us do is manage certificates for both dynamic websites and static websites in one place within our infrastructure without depending on someone else who's issuing certificates. So we don't rely on ACM in AWS. We don't rely on Cloudflare or any other CDN provider to issue these certs for us. We have complete control, and we can import these certs into any kind of infrastructure as and when needed. So that's been great for someone like us because we use several different environments in the cloud. So just a quick recap of our flow. We start out by issuing requests from our API, our Go API, and then using the cert-manager Go libraries, ultimately to the cert-manager custom resources. And that's where, cert-manager creates a request and an order and a challenge. You're all probably familiar with that flow. And then for the challenge, it creates, at least for the HTTP/01 challenges, which are the majority of our challenges, it creates these Acme solver pods. And that is where we use an ingress, which cert-manager needs to create paths to solve these Acme challenges. But we don't really use anything inside that ingress directly. What we do is run a proxy which directs all the Let's Encrypt HTTP validation requests to our load balancers, which recognize it as a Let's Encrypt request, and then they backend to the solver ingress, which is simply backending to this service, which is responsible for making sure that we pick the right ingress path or right solver pod to redirect the request to. So the solver pod is available, and our proxy is basically taking the paths in the ingress and directing the request or proxying the request to the solver pod. So solver pods are happy, the challenge is solved, certs are created. So that's the creation flow. Then we have everything in green is stuff that happens after we create the cert. So we have an informer that's listening on cert creations in Kubernetes. And again, we use the CRD Go APIs, Golang APIs there. And as soon as we find a new certificate creation or a certificate update with new values, we run through a series of steps, including persisting the data, encrypted data in a database. And we have listeners on that database that load them into our load balancers. And then we also export the certificates to wherever they might be needed. So for example, we use some third-party CDNs and they allow us to import our own certs, and we use cert-manager issued certs in those cases. And so this flow has worked from the very beginning. It works great. We're able to issue HTTP01 challenges within almost always under 5 minutes, usually 2 to 3 minutes. And this is something that we keep track of because there are so many certs, and because the controller is going through its loop where it tries to reconcile everything. So that is a good transition to some of the things that we've learned over time that help with scale. The right-hand side is just an image of like all our PRs that we've raised. And up until now, I was sort of the primary person at Render until fairly recently, responsible for dealing with cert-manager and coding up those flows. But as we've grown and as we've added more people to our team, more people have gotten involved, and I'm slowly transitioning away from our cert-manager infrastructure, but I'm still quite involved. And so a lot of these PRs have been, they bring back memories from, going back all the way to when we upgraded to 0.7 in late 2018. But one of the things that I'm sure a lot of you run into is Let's Encrypt limits. And I think it's different for us because a lot of the certs that we create are for our individual subdomains. And we create individual certs for our subdomains, which are of the form yoursite.onrender.com. We create individual certs for them instead of using a wildcard cert because we don't want to export secret keys to infrastructure that we don't control. Or we don't want to export our wildcard secret key to anywhere outside Render's infrastructure. So it's a security thing, really. And so we create a cert for every domain and the www version of the Apex domain. And that obviously leads to a lot of requests to Let's Encrypt, and especially when you count renewals. So we get around the limits because we are on the public suffix list, which is an interesting thing we discovered as we were running into these limits. The public suffix list allows hosts like Render who are giving away subdomains to have higher limits. Let's Encrypt internally uses the PSL to decide on limits. And then we also sponsor Let's Encrypt. That is not, again, that's not a workaround to get higher limits, but it helps because we have people we have access to folks at Let's Encrypt who we can get in touch with when things go wrong. It's almost never needed. I think we're at a point where we haven't had to reach out to Let's Encrypt in months now. So, but early on, I think it was useful, and they're also pretty responsive in their forums. So overall, again, super happy with Let's Encrypt and all the people there. We've had to tune some parameters. So the max concurrent challenges is perhaps the biggest one for us. This is a hidden parameter. It doesn't really show up in the docs except for maybe in the troubleshooting section. And this allows us to have as many challenges as we need at any given times. And this controls, so cert-manager internally does not create a new challenge if you have exceeded this limit, which is set to, I think, maybe 40 or something in the workflow, in the code. And obviously we have tons of challenges going on at any given time, and so we need to tune that limit. And then we've also, there is the CNAME strategy parameter, but that's an issuer parameter. And so for our wildcard certs, we use the strategy, which is extremely helpful because we don't host DNS for our users yet. So all we ask for them is to point to a subdomain, a unique subdomain within render that we can access. And then for that CNAME, we can manage the DNS challenge. And that works great. And I was so happy to see the CNAME follow strategy when it was added to cert-manager. Sorry, I got a weird. Oh, hold on. Okay, you can still see my screen. Great. So another thing that we've had to think about over the last 2 years is just Kubernetes versioning and dealing with client Go. And we're super happy to see 1.0 for this reason. The problems that we've run into with Kubernetes version specifically are more around being stuck with GKE having older versions. And so when we moved to other clouds, we just started managing our own kube clusters with kubeadm and soon cluster API, which looks great. And so sometimes we weren't able to upgrade the versions as frequently as we'd like, but we still wanted new cert-manager functionality, and so there were sort of some incompatibilities there. But I think we're in good shape now. And again, cert-manager has been great at helping with detailed upgrade instructions. I think if you're ever upgrading, there is the standard upgrade flow where you just update your manifest or use Helm. But they always have instructions that are version specific, and they're extremely detailed. You can literally just copy paste a lot of those things, and we're very grateful for that. It's not that easy to kind of anticipate all the ways in which a new version can fail, and I think it speaks to the quality of the cert-manager team, where they do anticipate these things, and they are diligent enough to write docs for them. So that's a little bit about sort of some of the things that we've learned, and I'm sure we'll continue to learn more as we scale even more. We've definitely had some issues with the 1.0 release, which I think we, again, because of our internal client Go versions, but we're looking forward to fixing that in the next couple of days. Cool. So things that you absolutely should be doing when you're managing all these certs, like we do, unit and integration testing for cert issuing. So cert-manager has this nice little package which helps us test it in our own tests without needing access to the Kube API, the fake client set. And that works great whenever we need it. But also for these tests, we've used github.com/maxbrunsfeld/counterfeiter. If you have code in Go, counterfeiter works really well to generate all kinds of dependencies that you wouldn't have access to in unit tests and integration tests. And then for end-to-end testing, we use the amazing Let's Encrypt Pebble server, which is meant only for testing, not for production. They make it very clear on their README over and over again. But it helps us test these flows before we roll out any upgrades or any changes to our cert infrastructure. And we're always thinking about ways in which the system can break, and testing doesn't go all the way. I wish it did, but there are some things that you just need to test in production. And so we're always making backups, or at least regularly. I wish we were backing up our certs more frequently, but that's an issue, open issue. And we're constantly making sure that our certificates are being issued within a certain time, because our users are very sensitive to that. They can't start using their new custom domains on render, or even their on render domains, unless a cert is issued. And we have this certificate pending status in our dashboard for them to see, and they want it to turn to green ASAP. And so it is important for us to make sure that that happens quickly, because we need to we want to avoid questions around, hey, why is my cert not being issued? It's been an hour. And that has happened at times, and we've caught these issues and subsequently fixed them. So it's an ongoing thing. I think Cert Manager, until now, it hasn't been at a point where we can just set it and forget it for our volume. But I don't think that will ever be the case for something like this that involves so many moving parts. And so it's always essential to be monitoring things in addition to having tests in place. Another thing that we realized as we were running this is Cert Manager itself the controller has a sync loop. And I think by default, it's set to sync every 60 seconds or so. And it's a resync loop, really. And we need to dig a little bit more into it. But for our use case, the resync loop, for every 60 seconds, going over 20, 30,000 more certificates and resyncing them just doesn't work, because it blocks the other certificates from being synced or created. And so one of the things we noticed was in our watcher that we're looking where we're looking for new cert issuances and things like that, we're actually making sure that we give enough time for the sync to happen before starting a new loop, and that allows us to issue new certs as and when they get created. So I think that is, at a very high level, our Cert Manager story. Let's open it up to Q&A. And you have my email, and you can reach us in render.com/chat.
Thank you very much. I didn't see how many certificates issued. Yeah, I have one question from Josh, but you already answered that during your talk about the scaling issues of the controller itself. A second one from the chat is, who carries out the anti-phishing checks?
Who carries out the anti-phishing checks where? Here? What does here mean, Dhruv?
I think that means...
You mean at render?
I think the whole platform.
So we have a separate system for that. Cert Manager isn't really involved there. I'm not sure. Maybe I'm not understanding the question correctly. But we can move on.
Are there any other questions? Now is the time to post it in the chat over there, and now I'm pointing in the right direction.
Another thing on scaling the controller, we just throw a lot of resources at it. I think vertical scaling goes a long way until it doesn't. And we're looking forward to being able to run multiple Cert Manager controllers in our cluster at some point. And I think that might be something that we contribute to Cert Manager code if and when we need it. For now, that's been fine.
PR is welcome. I don't think there are any questions. You can still contact on your email if they have some. You can also probably still go in the YouTube chat a few minutes after. So thank you very much. It was a very interesting talk.
Oh, sorry, there's just one more question from Josh. Are you using the certificate request resource directly? No, we're using the certificate resource. We're not using the request. We let Cert Manager create the request. So we just issue a creation request using the certificate Yeah, you're right. It should be possible, but we're not going to mess with cert requests if you guys already know how to handle that.
Thank you.
Cool. Thank you. Thanks a lot. Yeah, and if you have more questions, yeah, like I said, feel free to reach out over email or render.com/chat, which is our general user community Slack. And you don't need an invite to sign up there. You can just sign up.
That's amazing. Thank you very much.
All right. Thank you.
So this is the end of the cert-manager Community Day. Thank you for coming, everybody. Thank you, everybody in the chat room, for asking questions. Thank you to my Dell XPS over there, who's been handling this very well all day. Thank you to my mixer. Thank you to all the cert-manager team for contributing to this. I can't say thank you enough today. I hope we can maybe do this a second time. We'll have to look into that. But thank you very much for joining, everybody. See you next time.